A mega drought might hit Australia soon, and this isn't just about a couple of dry seasons. We're talking about 20 years of little or no rain. While Australia could be facing the longest and most devastating drought since official records began, the rest of the world might struggle to buy bread, flour, or cereals. Energy prices are likely to spike globally, and neighboring countries like New Zealand, Indonesia, and Malaysia must be prepared to receive Australians directly affected by the lack of water. To truly understand how severe this situation could become, we should first examine past disasters. First off, Australia is no stranger to droughts, and this phenomenon can happen across their entire territory. From 2017 to 2019, the southeast part of the country went through what they call the tinderbox drought. This was a severe bone-dry event where the cooler months saw only about half the usual rainfall. Parts of Australia became so dry that wildfires were a constant threat. Crops failed, and water was scarce. This drought was also thought to have contributed to the Black Summer fire disaster. By the end of 2019, bushfires were raging across the country on a scale never seen before, with people describing them as rivers of lava flowing down from treetops. The losses were staggering. The tourist industry alone took a hit of $2.8 billion, and over 7,000 jobs disappeared as a result of this difficult period. The tinderbox drought was a big reminder of what Australia might face in the future. That's why it's so important to understand what happened in the past to get a full picture of a possible 20-year mega drought. But there is one problem. Even though droughts are relatively common in Australia, the rainfall data available until today isn't enough for researchers to predict the future, and our records only go back to around 1900. So experts decided to study tree rings to uncover missing environmental data. If you look at a tree stump, you'll notice concentric rings on its surface. As trees grow, they form new rings, and the thickness of these rings depends on how much water they get. During a megadrought, the rings appear thinner because the trees don't have much water. Unfortunately, these natural records usually only go back a few hundred years, and it only tells us about specific local conditions, not the situation across all of Australia. So, experts turn to computer models to simulate how Earth's climate changed from the year 850 to 2000. This approach helped them to paint a picture of when megadroughts might have occurred in Australia and how to predict what might happen in the future. But what they were really interested in was whether the human factor might be making this scenario worse over the years and if we are somehow intensifying these dry periods. So, are we to blame for these megadroughts? The short answer is, we're not sure yet. On one hand, dry periods in Australia do seem to last longer than they did before factories and machines became common. On the other hand, they don't seem to be getting more intense or happening more often than before industrial times. This means a drought lasting 20 years might not be directly linked to human activities. Actually, this kind of phenomenon is just a normal part of how rainfall changes in Australia over time. This is backed up by evidence from ice cores, which suggests that a 39-year drought hit eastern Australia around 800 years ago. What makes it all so fascinating is that there isn't just one cause for this phenomenon. I mean, there is no single mechanism that explains all cases of megadroughts. It happens because the right combination of ocean and atmospheric conditions come together, and you end up with a drought. And just by random chance, you might have periods where there are 100-year-long droughts. Despite what many people think, megadroughts are not geographically isolated. They have occurred on every continent except Antarctica over the past 2,000 years, and are often linked to natural events. For instance, megadroughts in North America and Southwest South America were driven by El Niño, where the Pacific Ocean near the equator gets warmer than usual, disturbing normal weather patterns. They are not rare events either. In fact, the U.S. Southwest has been experiencing a megadrought since 2000. It's being considered the driest period in 1,200 years for the region. Major reservoirs like Lake Mead and Lake Powell are at low levels. Heat waves are hitting cities like Phoenix and Las Vegas harder than ever. and wildfires are happening more frequently as the land gets drier. Now, let's think about the future. Even though we have a very recent and concrete example from the US, research can't exactly predict how a 20-year megadrought would play out in Australia. Usually, such events show up mainly as reduced rainfall and snowfall. But in most areas, the increase in drought risk will be caused by a warmer, more arid atmosphere. So the ground will probably look parched and cracked, rivers and lakes will likely shrink, and the sky will be relentlessly clear and blue, with barely a cloud in sight. Farmers might struggle to grow crops, making grocery prices rise worldwide. Things like bread, flour, and cereals may become scarcer, as Australia supplies about 13% of global wheat exports. Coal mines might be affected, as they depend on water for extraction, washing, and processing. That might drive up power costs for industries around the world, which could be passed on to consumers, impacting global growth and inflation. As cities might face water shortages, Australians will likely find new ways to conserve every drop or maybe move to New Zealand or Southeast Asia. Now, you're probably thinking, when is this big event going to happen? Honestly, it's really hard to predict exactly. Megadroughts can happen every 150 to 1,000 years, but experts think Australia should be ready for one to happen in the next 10 years or so. And this possibly should be taken seriously. This phenomenon has been known to contribute to the collapse of entire civilizations. Take the Akkadians of Mesopotamia, who built the world's first empire more than 4,000 years ago. Studies of moisture at the ruins of Akkadian cities suggest that they experienced a massive drought lasting 300 years, and this may have led to their collapse. A similar thing happened to the Assyrian Empire, which existed over 2,700 years ago, in what is now northern Iraq. For years, it was a real mystery why they left their capital of Nineveh and never returned. But recent studies of a stalagmite in the Cunaba cave revealed that the rise and fall of the empire coincided with a wet period followed by a 125-year-long mega-drought. Because they were very dependent on seasonal rain for agriculture, this dry period made their life much harder. Even though experts now believe they probably left because of the dryness, the question of where they went is still a mystery. So, yep, mega-droughts may have played a role in the collapse of great civilizations in the past. But on the positive side, we've come a long way since then, and recent climate technologies can help us prepare for events like this. Now that we know a 20-year megadrought is very much possible and might happen soon, Australia has some time to get ready for it. Developing strong water management plans to mitigate the severe impacts of a megadrought is more than necessary, and it's also important to create community support networks to provide emotional and financial support to people, particularly farmers, who are more affected directly by this event. If initiatives like these emerge in the coming years, those 20 years of drought could be less intense than most people might expect.
For every 1.8 degrees Fahrenheit increase in a country's average temperature, the GDP per capita drops by at least 1.1%. To put it simply, with every step you take from the North Pole to the equator, not only do you get hotter, but you also get poorer. Even though life in freezing cold countries can seem miserable, 74.2% of the world's billionaires are concentrated in the global north. And there are at least 4 theories explaining that. The simplest theory is tied to biology. Cold weather is believed to keep germs away, leading to better health and productivity. Sounds good, but I'll challenge that later. Next, there's the sloth theory from ancient Greece, and it's more about climate in general. Greeks believed their ideal weather made them wealthier, while hotter regions were seen as less creative. The third idea is based on economic and anthropological studies. You see, experts noticed some time ago that colder countries have inclusive institutions that offer equal job and life opportunities and protect markets and private property. Naturally, such conditions promote healthy competition and boost wealth. The last idea is tightly connected to the previous one. Long story short, Richer countries tend to distribute money better because they're more inclusive. Poorer nations often have extractive institutions where a powerful elite controls wealth. While all of them seem plausible, the truth is, these ideas are borderline insane. Well, you know the theory claiming that cold climates eliminates germs and the population of colder countries doesn't get so sick? I don't want to be the bearer of bad news, but the cold actually makes germs thrive. In the cold, we tend to stay inside with the whole house shut, so we share germs with each other more easily. Not only that, but during winter, the air is drier, creating the perfect environment for the flu virus to flourish. Humans are also more resistant to viruses and bacteria from their own environment because the constant contact with them makes our immune system stronger. If you look back at your history classes, you might remember that most British people struggled with the weather and bacteria found in America, while Native Americans themselves were mostly fine. And what about the sloth theory? Sorry, I don't mean it to sound offensive, but some specialists, they claim that, people in hotter countries tend to be lazier. But the truth is, the sun doesn't make us work less. Yes, the sun can make you a bit slower because you can dehydrate. But you see, the human body is biologically adapted to the climate of the place they're born in. This means that if you live in Canada, for example, you can endure the cold just fine. But Brazilians will probably handle hot days better than you. But if the sloth theory was true, how would you explain that people in Colombia work about 200 hours a year more than those from the United States? In fact, if you live in Cambodia, Myanmar, or Mexico, you're bound to work more than anyone in the world. Besides, hotter countries have a genius way to fight off laziness. It's called siesta. After lunch, it's normal to feel a bit sleepy, and if you have heavier meals like the Spanish and Italians do, you'll get extra slow. This is why after lunch they usually have a siesta, also known as a quick nap, which improves your memory and thinking skills. It may sound like a siesta makes you work less, but people who nap after lunch simply work at different hours of the day. While you make shorter lunch breaks and go home at 6 p.m., in Spain, the lunch break lasts 2 hours and the workday ends at 8 p.m. They work when it's not so hot outside and even get to take a power nap. The past is also crowded with people who lived rich lives despite the scorching sun. The ancient Egypt civilization may have existed thousands of years ago, but they were one of the richest civilizations ever, even though they lived in a place that was super hot and super dry. We also have the Aztecs, who lived in Mexico back when Mexico didn't exist yet. This region is not so famous for its cold weather, I can tell you that. But the Aztec civilization still managed to have a capital that was bigger than London, Paris, and Madrid of the time. On top of that, many of the inventions we have today that make a lot of people rich were created thanks to math and science. Two things born in hot places, like Mesopotamia and India. Now, to make all those economic and anthropological studies sound simpler, let's start with the most obvious part. It's true that hotter countries usually make money out of their natural resources. They don't have such strong industries, and the money is concentrated in the hands of the elite. All of this reduces the GDP, that thing that estimates whether a country is wealthy or not. Remember we said richer countries have inclusive institutions? These institutions are basically laws that make sure people have equal job and life opportunities, including nice houses and a good salary. Poor countries are not very good at this inclusive institution thing, but it's not by choice. This is actually a consequence of the age of exploration. In case you were sleeping during your history classes, let me remind you. The age of exploration is that time between the 15th and 17th centuries, when many kingdoms in Europe were exploring the seas and setting up colonies all over the world. I know it feels like this was a long time ago, but many countries that were colonies back then only became independent during the 20th and 21st century. This is why many poor countries don't have solid industries and markets, because their institutions and laws date back to when they were still colonies, and their years as colonies depleted resources and didn't provide a good infrastructure. Besides, saying that private property reduces the income and inequality gap is kind of absurd. It's true that developing countries like Brazil and South Africa are highly unequal, but in the US, for example, 1% of the richest people in the country make 139 times more money than the poorest part of the population. And there were more than 700,000 homeless people in 2024. Besides, 1% of the world's population is wealthier than the rest of humankind put together. If inclusive institutions were really that powerful in richer countries, then there wouldn't be more than 1 billion people living in acute poverty all over the world. There's no point in saying that private property makes everyone's lives better if people can't even afford to have a house in the first place. And using the GDP to calculate the wealth of a country is not exactly the best way to understand poverty, because the GDP only considers how much money the industry itself makes. It ignores, for example, the question of whether people who work in those industries have good jobs, if they are well paid and have a good life. The GDP also ignores inequality, which means it ignores those inclusive institutions we mentioned before. In the United States, there are about 835 billionaires, but 11% of the American population is still very poor. So, my hot take here is that inclusive institutions are not that inclusive, and that money is not that well distributed in the first place. Different cultures also have different concepts of what it means to be wealthy. In London, for example, being able to afford food, clothes, and shelter does not make you rich. To them, you're simply surviving. If you want to be truly wealthy in London, you might have to hire a housekeeper, buy a horse, and have a personal Pilates instructor. But to the Awa or the Yanomami tribes, money doesn't even exist. They produce only the necessary, and if they have a surplus, they will trade with other tribes. I guess the fact that poor countries are all located closer to the equator line is not just a simple historical coincidence.
Why is Australia so strangely empty? Why haven't we discovered so much of the ocean? Is our planet a perfect sphere? And was the Earth once more purple than green? I bet you didn't know these facts about our planet. So let's find it all out. Australia is really massive. To make it easy to understand its size, it's nearly as large as the entirety of Europe. Home to around 26 million people, Australia is among the countries with the least population per area. It's ranked only 55th for the highest population in the world, while it has the 6th largest land area. Why is so much of it empty? A good guess would be the many dangerous animals hiding behind every rock. At least this is enough for me to avoid Australia. But there's one specific reason to explain this. The dryness of Australia ensures that 85% of the population lives within 30 miles of the coast, and 80% of them live along the eastern side, where rainfall is more common. But although there is an overall lack of rainfall, only 20% of Australia is unlivable desert, and only 40% is considered not habitable by human standards. The water consumption is actually higher than their average rainfall each year, but there is a further ancient water source hidden way below, which can support a much larger population. It's one of the largest underground freshwater resources in the world, the Great Artesian Basin. It covers a staggering 656,000 square miles, which is 1/5 the size of Australia. It holds enough water to cover the Earth under a 1.5 feet deep layer of water. Or, more usefully, it could provide enough water for thirsty Australians over the next 1,500 years. Only 6.5% of Australia has soil suitable for farming, so this doesn't seem like a huge amount. But in case you forgot, Australia is big, and this small percentage is about the size of France. With this massive area available for farming, Australia has more than enough to feed its population, with a further 70% of agriculture products that are exported overseas. So, with plenty of land, food, and water, why are the population figures so low? A very slow migration process is the reason. First, only people from the United Kingdom lived there. Then, they opened their borders to other Europeans, and this restriction remained in place until 1973. You would think almost 200 years would be enough time for a lot of people to migrate, but Australia was just so far away. The risk of traveling such a long way and the cost of the journey meant that people from Europe prefer the shorter and cheaper options to migrate elsewhere, like Canada or the USA. For the past 2,000 years, people have understood that Earth is round. But did you know that it's not a perfect sphere? Through the wobbly rotation of Earth, our planet constantly changes its size, very slowly of course. The North and South poles are surprisingly flat. Earth is pretty much like a ball being squished. Imagine there's a giant hand with the fingers pressing at both poles. Because of this pressure, the equator pushes a little outwards. Along with an uneven gravitational field, Earth has loads of gravity glitches, some positive and others negative, creating an uneven, rocky, and bumpy surface. Some places on Earth have more gravity than others. If you weighed yourself along the equator, you would weigh 0.5% less than at the poles. Not a whole lot, and definitely not worth the trip to change your weight. If you were to measure the length from the center of the Earth towards the furthest point of Earth, you would be shocked that Mount Everest isn't at the end of it. Instead, it's along the equator, which is the pushed-out part. Ecuador's mountain Chimborazo would actually be the tallest point on Earth, as it's the furthest from the center. We still have around 80% of the ocean to map, which is crazy considering how much of the solar system we've explored in comparison. But we're still aware of many of the unbelievable details about the ocean. It covers over 80% of the world's surface, where 94% of the Earth's wildlife lives. And from some of the life in it, up to 80% of the world's oxygen is produced mainly from plankton, algae, and bacteria. One of the most famous, already mapped places is the Mariana Trench. It's the deepest point on Earth, as low as almost 7 miles deep. That's a huge, 5 times the length of the Grand Canyon, and deeper than Mount Everest is tall. It's also home to one of the most ancient seabeds on Earth, casually laying low for about 180 million years. The pressure at the bottom is over 1,000 bars, but although this is 1,000 times more than normal pressure, life still flourishes here. Throughout the ocean, there is an estimated over 3 million shipwrecks lying in the murky depths. Countless artifacts sit there untouched, and there could be more than all the world's museums. The mid-ocean ridge is the longest in the world, reaching 40,000 miles. That's almost 10 times the size of the Andes, the longest mountain range on land. The sun is the reason behind the blue and aqua colors of the ocean. This color isn't from the reflection of the sky, though they are both blue for the same reason. The surface of our planet receives white light from the sun, and it absorbs the orange, red, and yellow light stronger. It doesn't absorb the blue light so much, so it returns to how we see it. Of course, this only occurs based on how pure the water is. If the water is full of mud or algae, they scatter the light and overpower the water's natural blueness. There are many factors that determine what color we see on our planet. Could you believe that the Earth was green before? Instead, it was purple. Chlorophyll in our atmosphere absorbs mainly blue and red wavelengths from the sun and reflects the green ones to what we see our planet as today. Long ago, ancient microbes called retinal dominated the Earth instead of chlorophyll. They absorbed green light and reflected red and violet light. Those microbes had a simpler structure, so they were easier to produce in the low oxygen environment of the early Earth. They provided our planet with a purplish color instead of green. But chlorophyll is more efficient, and as the Earth was developing, it eventually took over. Imagine that billions of years ago, faraway observers could see our home as a small purple dot. I wonder if we could have also been purple. Probably not. The biggest tree on Earth is a giant sequoia named General Sherman. It stands over 280 feet, almost reaching the height of a 26-story building. They believe it to be 2,700 years old, with a circumference of 1,000 inches. Its weight is a staggering 1,800 tons. That's heavy, but it isn't the heaviest living thing on Earth. In Utah, a huge grove of trees called pando works like a single colony of trees. The massive root system connects all of them together with up to 47,000 stems. It weighs up to 6,000 tons and is 80,000 years old. It makes it the oldest living thing known to humans. Now, what about the biggest area of one being? Off the coast of Western Australia, a seaweed grows to an unthinkable size. The Poseidon's ribbon weed has been growing for 4,500 years, spreading underground clone shoots. It's all connected and shares the same DNA with most of its shoots. It covers a massive 77 square miles, the same size as 28,000 soccer fields, or the size of Nebraska. And it won't stop there either, as it continues to grow by 2 feet each year. It's hard to even picture the scale of these enormous beings. Now, just imagine if they were all purple.
Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and is called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, maybe too late for that, but I'll try, the ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please.
The world's largest fence spans over 3,100 miles from Queensland to South Australia. If stretched out, it could easily connect London to New York. And if you'd walk next to it, you'd need 6 months to complete the journey. It wasn't built to safeguard the Australian border. Why would it, since Aussies are just surrounded by water? It wasn't meant to protect some important building either. Its purpose is to keep some animal species away from each other. It was back in the late 1800s when Australians started building parts of this fence. They wanted to create a barrier separating the lively, bustling part of the country where cities like Melbourne and Sydney's thrive from the harsh, dry outback. They used wooden posts dug deep into the ground, linked up with wire mesh standing about 6 feet tall. Some parts of the fence even have a second electrically charged layer. To make sure this fence did its job, they added some red and white lights to help guard things even at night. A team of over 20 people work full-time to keep things in check here. And every year, local authorities chip in around $750,000 to keep the construction in shape. Why all this trouble? The main reason was dingoes. These gingery, wolf-like creatures are Australia's largest carnivore mammals, and they're also apex predators. They were causing a lot of trouble to local farmers, especially in southern Queensland, where they often go after sheep. For the most part, the fence has been doing its job okay, but it's not foolproof. Some dingoes still manage to sneak through. Other times, wild camels end up crashing into it. That's because Australia has quite a massive camel population roaming around. But this man-made solution did more than locals expected. They thought there would just be fewer dingoes within the fence, but fewer dingoes mean more kangaroos. And more kangaroos mean more competition with the sheep for food. It's not just the bigger species feeling the squeeze. The smaller animals and the greenery also went through changes. With all this competition in a smaller space, locals noticed less diversity in the plant life and small animals. The soil became less nutritious over time, affecting plant growth. Plus, the fence acts as a roadblock for animal migration and seed dispersal. Even the sand dunes are feeling the effects, with less grass cover to hold things together. When scientists looked at kangaroos on both sides of the fence, they noticed that the young pups inside were lighter and tinier on average. The outsiders had bigger feet and heads for their age, and it wasn't because they were eating a different diet. The kangaroos that were stuck sharing the land with dingoes had to bulk up faster to survive. On the flip side, those inside the fence took it slower because they weren't under the same type of pressure. These had to compete with a lot of other creatures for food, so a bigger size wasn't a priority anymore. Researchers are still not sure if this difference is a quick fix or a long-term gene adaptation. What about domesticating dingoes? Wouldn't that help? Many think dingoes were once pets in Australia, but it's not known for sure. These days, they're pretty wild, just like wolves, hyenas, or coyotes. Most of them don't need packs to survive and are solitary hunters with sharp instincts built in. So taming them isn't going to be easy. Still, taking down the construction is not an option for now. Australians are so strict when it comes to making sure dingoes are kept away that they even put laws in place for people who mess up with the fence. Leaving a crossing gate open can put people behind bars for up to 3 months. Damaging the fence can cost people 6 months' worth of their freedom. It wasn't the first time Australians thought a fence could help with animal issues. Before they needed it for dingoes, they experienced a serious bunny invasion. Cute as they are, rabbits were damaging the land used for farming, so locals thought of a three-part fence. The first one stretched all the way from Ravensthorpe in the south to Pardew Station on the Pilbara coast. It was over 1,100 miles long, making it the longest unbroken fence globally at the time. All these bunny problems could have been traced back to a man named Thomas Austin. Back in 1859, when he first came to the land down under, he thought it would be a good idea to release a few rabbits into the wild, thinking it would add a bit of charm to the place. But since rabbits aren't native to Australia, they didn't have any natural predators at the time. They're also pretty adaptive creatures, needing just some grass for feeding. They reproduce at astonishing speeds too. A mama rabbit can have 4 litters a year, with as many as 5 bunnies each. Pretty soon, their numbers boomed. By the late 1880s, the bunnies had caused so much damage that local authorities came up with a proposal. They'd offer the equivalent of almost $2 million today to anyone who could come up with a solution to this long-eared problem. Nobody claimed the prize, but a commission did gather a bit over a decade later and came up with the fence idea. Maintaining those fences was complicated. They had inspectors keeping an eye, with each one responsible for a stretch about 500 miles long. There were also these boundary riders patrolling smaller sections, using bikes at first, then switching to camels or using camels to haul buggies. They even tried using cars at one point, but they couldn't handle the rough terrain and constantly had punctured tires. In terms of its effectiveness, well, by 1902, rabbits were already hanging out on the wrong side of the fence. That's why, 4 years later, they put up another one. It worked for a while, so much so that the local authorities didn't bother helping out farmers past that second fence with rabbit netting loans. Those caught between the two fences, however, still had a rough time dealing with rabbit trouble. Soon enough, rabbits spread even over fence number 2, and it was clear the solution didn't work. In some areas, even while the fences were being built, those sneaky bunnies found their way past them. To this day, the rabbit population still sometimes puts the Australian officials through rough times. The dingo fence may be the longest one, but it's not the weirdest. The aquarium fence in Turkey might take that prize. This 164-foot aquarium fence was built to make sure the expensive villa's ocean view would be visible from every one of its levels. These days, it gathers a lot of tourists from all over the world, eager to see the variety of fish it contains, and even the octopuses. Putting up a see-through structure wasn't hard. The real challenge was connecting the aqua fence to the Aegean Sea through a buried pipeline stretching across 13,000 feet of land. This ensures water constantly flows, keeping the aquarium clean and the fish happy. To make sure no one damages the delicate fence or steals any of the fish or two, the owner also invested in security. He installed a network of 17 cameras equipped with facial recognition. Visitors are free to look and take pictures, but step too close and you're likely to trigger alarms. Another one of those weird fences is New Zealand's bra fence. If you ever find yourself through central Otago, you might stumble upon a fence adorned with bras of all kinds of shapes, sizes, and patterns. Its story takes us back to 1999, when people in the area found 4 bras mysteriously hanging on the fence near Cardrona Valley Road. Some were a bit surprised, but then others started adding their bras to the decor. Some more bras appeared, and it became a must-see spot for tourists. Its popularity was so high that at times it caused traffic problems in the area.
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the U.S. was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle, near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So a derecho is kind of like a small, average level 1 to 2 tornado. Usually, its speed is within the range of 73 to 113 miles per hour. And, in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, scientists don't have an exact explanation. But, although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, The sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen.
So many asteroids pass through our solar system, and we don't even know about it. Those are rocky pieces of material left over from the time when our solar system was forming, about 4.6 billion years ago. They move around the sun, but not in the way planets do. We're talking about true rebels that prefer to follow some pretty strange paths. Plus, they spin in different ways as they travel between planets and other space objects. And the majority of them come from the main asteroid belt that's located between Jupiter and Mars. Most stay there. But Jupiter has quite a strong gravity, so it can push some of those flying rocks in different directions, and towards us too. They're sometimes round, and sometimes they have odd shapes, with pits and holes from all that crashing into other space rocks. As we currently know, there are more than 1 million of them in the main asteroid belt, and that's all good until some of them move in our direction. NASA keeps an eye on them, so we know everything's fine, at least for now. But that wasn't always the case with our beloved home planet. If Earth could talk, it would probably share so many crazy asteroid stories. We're talking about those space rocks that left impact craters we call domes. They have a specific shape with a raised center, similar to when you throw a pebble in a pond and see some water splashing upward. But we'll never be able to learn about many others. I know this raised center sounds like something you're supposed to see right away, especially if an asteroid that once slammed into the surface was big, But we're talking about millions and millions of years of erosion, so wind, water, and even gravity do what they do best and erase traces. They wear down impact domes, and some sites even end up hidden under layers of rock and dirt, or they disappear forever because Earth's tectonic plates keep moving around. Check out the Moon. It's experienced many collisions too, but over there, there's no ocean or tectonic plates moving around, or even wind to slowly, through millions of years, erase craters from its face. Basically, its entire history is written on its surface. But Earth has its own forces that can erase such places as the Vedafort impact structure and the Chicxulub crater. You know, the famous one that wiped out the dinosaurs? Luckily, scientists have new methods to find ancient craters. They often focus on the mess impacts made, which means the materials they threw around. And the Australian continent is especially interesting since we're talking about a playground for asteroid hits. By that, I mean ancient supercontinent Gondwana that dominated the South hundreds of millions of years ago. Experts know about 38 impacts, plus they speculate about 43 more. Some structures are relatively small, while others are big and completely hidden. And recently, a scientist named Tony Yates has discovered strange underground magnetic patterns in New South Wales, Australia. Yay! New clues of a giant asteroid impact. And when I say giant, I really mean it. It's a structure 323 miles in diameter. This might be the largest impact site ever found. This spot is called the Deniliquin structure. Its magnetic patterns show characteristic ripples around the center, like when a rock hits the water. There are also fractures that go outward from the center. And it seems rocks from inside Earth ended up pushed into these fractures. That's a typical story for big asteroid impacts. This structure was probably located in eastern Gondwana hundreds of millions of years ago, way before it split into several continents, including Australia. At the moment, all we know about this crater is what we see on the surface. To find more information about this collision and get some proof, we'll have to drill into the ground. An asteroid this big is definitely not a joke. It could have caused a massive ice age and maybe even wiped out around 85% of species, even more than the asteroid that ended dinosaurs. In 4.5 billion years, which is how long our planet has existed, it's been punched by hundreds of big asteroids. But that doesn't mean every space rock that enters our atmosphere really makes it all the way to the ground. Most of those that manage to pass the atmosphere are relatively small, for instance, 3 feet across. That's good for us because any space rock that's less than 82 feet in diameter most likely won't make it past our planet's atmosphere. Since these space rocks come towards us very fast, they heat up the gases in the atmosphere, which burns them away. By the way, once cosmic intruders enter our atmosphere, they turn into meteors. And in most cases, they don't cause much damage, if any, as they fall down. But we used to have way larger things flying around and crashing into Earth. At least 190 of them have left scars you can still see today. One of the really big ones is in South Africa. It's 99 miles wide. It's actually the largest. At least that's what scientists think at the moment because they still need to check as many details as possible about this new crater in Australia. This one in South Africa formed about 2 billion years ago, and an asteroid that created it was probably larger than the one that had wiped dinosaurs away. And when an asteroid is bigger than 0.6 miles, it can have really big effects across the world. This impact was so strong that it could have caused fires everywhere and thrown lots of dust into the air. And when you have so much dust in the atmosphere, the climate on the planet can change for months or even years. Then we also have the most popular asteroid that made a giant hole we today call the Chicxulub crater. You know the story. It crashed into our planet 66 million years ago when dinosaurs were wandering around, catching food, falling in love. Basically, just doing their thing. The crash itself didn't erase them right away. It threw a lot of debris into space, and when it fell back to Earth, fires and flames were everywhere. The hit also produced a big cloud of dust that covered the planet for years. This cloud blocked the sunlight, which harmed plants and entire food chains. Even those dinosaurs that survived the crash and such difficult conditions had a hard time finding food, so they didn't make it. At least they left us many fossils and turned into the inspiration for movies and stories. A long time ago in Canada, something big crashed into our planet and left a big hole we today know as the Sudbury Basin. People used to think it was an asteroid, but now some experts think it might have been a giant comet made up of a mix of ice and rocks. The hole is almost gone now because of weather conditions though. But people still get to mine iron and nickel there, and at the same time find the leftovers of whatever space object fell there. If you move deep in southern India, you'll find a big hole called Lonar Crater. Locals stumbled upon it 200 years ago and believed it might be from a volcano. But now we know it's a trace from a meteor that crashed into the ground about 35 to 50,000 years ago. What's so special about this crater is that it's the only one known to have formed in a type of rock called basalt. Around the crater, there are hills covered in trees, and animals like peafowls and gazelles live there. Birds also like to visit the lake near the crater during the winter. And the lake itself is quite interesting too. It can turn pink because of all those tiny organisms that live there. But this color change doesn't last long.
June 29th, 1764, seemed like a regular day in one small picturesque town in Germany, Waldeck. Residents were in church. Little did they know that a powerful storm was about to hit the area. It wasn't just an ordinary storm. It was a strong, swirling tornado getting closer and closer. It was an F2 tornado at the beginning, strong enough to uproot trees like oaks and beeches. But as time went by, it grew and became more powerful. It even picked up 2 children on its way and threw them into a lake. Something strange happened too. The water level in the lake rose and then quickly retreated. Leaving the lake behind, the tornado struck a house, tearing off the roof and knocking down the walls. Then the tornado changed direction and headed east-northeast, increasing its intensity to F3 level. That's when something fascinating happened. A possible twin or satellite waterspout merged with the tornado along the shore of Lake Luzin. It was like 2 tornadoes coming together. It got wider and stronger, so it started snapping and uprooting solitary oak trees, flinging them 115 feet into the air. It left behind a barren landscape, removing crops, grass, and even topsoil. Back then, people couldn't even read or write very well, let alone use devices that could predict a tornado. This one was so strong it destroyed houses, barns, and even uprooted trees. Such a terrifying thing to see. But there was something special about the church people were in. It had strong stone walls, so they were safe inside, even though everything outside was getting destroyed. They didn't even realize how lucky they were until later. With winds estimated to be over 300 mm, it was unstoppable. The tornado traveled a distance of 19 miles and stretched to a maximum width of 0.6 miles. A raging storm threw tree branches so high, people believed they ended up in the atmosphere. Another strange thing about this tornado was that it occurred during a dry storm. There was very little rain reported, but the storm still managed to make such a mess. It even produced large hailstones, some as big as 5.9 inches in diameter. Just imagine chunks of ice that large falling from the sky. These hailstones caused significant damage to crops and properties, and everything else that was outside at that time. After the storm passed, one scientist, Gottlob Burchard Gensmer, studied the damage and talked to people who had witnessed the tornado, only to realize this was one of the strongest tornadoes ever recorded in history. It reached F5, the highest rating on what's called the Fujita scale, which measures tornado strength. It took an hour for the madness to stop. Back in 1925, people in northeast Missouri didn't have an organized tornado warning system either. It took them by surprise when one day, in the early afternoon, they saw a tornado forming in that area. At first, it was a small one that briefly lifted off the ground. But as time went by, it started growing into a massive monster. Meanwhile, in West Frankfort, Illinois, some miners were working deep underground, about 500 feet below the surface. Suddenly, the power went out, and they knew something was wrong. They quickly started climbing up the shaft to get to the surface. When they finally made it, they were in for a terrible shock. because of the devastating consequences of this giant tornado. The tornado didn't even stop there. It kept on making a mess as it traveled a long distance. It plowed through the land for a whopping 219 miles, all the way from near Redford, Missouri to the east of Princeton, Indiana. It moved at a crazy speed of 73 miles an hour. In one town, Murfreesboro, Illinois, the tornado wiped out a staggering 100 blocks of the town, plus another 70 blocks ended up destroyed by fire. In another town, Griffin, Indiana, not a single building was left standing. The tornado got weaker only at 4:30 in the afternoon. This tornado, known as the Tri-State Tornado, really made history as the worst and longest-lasting tornado ever recorded in the United States. In April 1965, people in the region of the Great Lakes started complaining about this weird heat. The forecast showed no storms for that area. It was because of thunderstorms sweeping across the upper Midwest of the United States. These storms were insane and so powerful they created 51 tornadoes in just 12 hours. The states of Indiana, Ohio, and Michigan ended up being hit particularly hard. Something unfortunate happened during this time. All this caught the forecast team, the National Severe Storms Forecast Center in Kansas City, Missouri, off guard. They quickly tried to send out warnings to let people know what was happening, but many people didn't hear the announcements because there were no outdoor tornado sirens at that time. Additionally, a lot of TV and radio stations didn't regularly broadcast weather alerts. Power was gone, and telephone lines didn't work, which meant many towns were completely cut off from communications. People couldn't receive the warnings because they didn't have access to electricity or working phones. One spring day in 1974 was especially hard because of severe thunderstorms that unleashed a series of powerful tornadoes across 13 states in the United States. These tornadoes lasted for 16 hours, and they ranged from weaker F0 to the most powerful and destructive F5 ones. At one terrifying moment, there were 15 tornadoes touching the ground at the same time. One lasted for more than 2 hours, and 2 others were swirling around each other like dancers. This was another big lesson, after which some changes in tornado warnings were made. In those days, weather forecasters could only warn people about a tornado if they had seen one with their own eyes, which was mostly too late. April 26, 1989, at around 6:30 in the afternoon, the sky above one district, Maniganj in Bangladesh, turned dark and ominous. The tornado began its journey from one point, Daulatpur, and moved swiftly eastward, Saturia, Maniganj Sadar. People living in that region had already been facing a severe drought, and little did they know there were even worse scenarios coming. The storm was fierce, stretching about 10 miles long and 1 mile wide. It covered a relatively small area, but it still caused enormous damage. It tore through the land and blew away buildings, thousands of trees, strong and rooted for years, and everything else in its path. The countryside of Marsala in western Sicily is really beautiful. But it wasn't so stunning on December 8th, 1851. 2 fierce tornadoes suddenly swept across the land, leaving nothing but chaos. As they moved, they brought along heavy rain and hailstorms, causing even more damage to the already vulnerable farmlands. One town, Castellammare, had an amazing harbor with plenty of ships, and it suffered great damage. The news of this devastating event reached far and wide, even making its way to the Illustrated London News. The outbreak in Oklahoma from 24 years ago, May 3rd, 1999, was tough too. Just one stormy day caused enormous damage from Texas all the way up to South Dakota. At least 45 tornadoes touched down, and Oklahoma was hit the hardest with an F5 tornado. The story seemed familiar. What first seemed like a small twister quickly grew into a massive force that, at one point, measured 1 mile in width. This one ripped asphalt from roads, peeling it away in layers like fragile paper. It tore the vegetation away and even wrapped roofing materials around power lines. NASA scientists studied the area using satellites. They realized it would take between 10 to 20 years for the vegetation to fully regrow in the region where the tornado left nothing but muddy, barren land. Oklahoma is in a pretty unfortunate spot when it comes to tornadoes. Take 1947 as an example. The Woodward tornado got named after the city it had struck. This monstrous tornado was massive, It reached 1.8 miles in width, and it raced forward at an incredible speed of around 50 mph. Before reaching Woodward, the tornado had already caused a lot of mess in other towns along its path. But it was in Woodward where it unleashed its worst fury. Without any warning, it struck the city at 8:42 in the evening, catching the residents by surprise. Communication with the outside world was cut off, leaving families uncertain about the fate of their loved ones. As if one tornado isn't enough, some areas get struck by a series of them. In 1908, an outbreak of tornadoes swept across the eastern part of the United States, from Texas to Georgia and then northward from Oklahoma to Tennessee. At least 34 tornadoes touched down. Nature showed no mercy. Buildings were torn apart, and once thriving streets were reduced to rubble. The Fujita scale measures tornado strength based on two things: the speed of the winds and the amount of destruction caused. F5 tornadoes are the strongest, most destructive ones. I mean, some people talk about F6 tornado with winds that could blow at over 300 miles per hour. If this one was passing by, you'd definitely know how Dorothy felt. Luckily, F6 exists only in stories, and Oz is the last place you are likely to end up at.
There are entire communities of unusual tiny organisms that live in lagoons in Patagonia, and they are some of the first forms of life ever. No one had known about them until two scientists, Brian and Maria, went to explore certain areas in Patagonia. Now, Patagonia occupies nearly half of Argentina, and few people live there. Only some farmers and sheep ranchers that mostly stay near rivers and grow things such as apples, pears, and alfalfa. A long time ago, it was a wild and distant place where Indian tribes lived. But this time, we're going to follow the tracks of life forms that appeared long before humans and look closer at these interesting microorganisms Brian and Maria found. Those two had to drive for 9 hours on some rough roads to reach their destination. They stayed in a small village. Only 35 people live there. These people depend on just one spring because it almost never rains there. On the last night in the village, Brian realized that satellite images he had taken had shown a set of lagoons that were only 10 miles away. The next day, the small team jumped into a car and went up the road as far as they could until it became too difficult to drive. They continued hiking the rest of the way. It was hard because they had to carry water to deal with the intense sunlight. In some spots, they ended up sinking up to their knees in a slush made of salt. Up there were 12 lagoons with perfectly clear waters. The place itself didn't offer much except for very acidic and salty water and intense direct sunlight. But it was kind of like traveling back in time, because those conditions were like what Earth looked like many, many years ago. When Brian examined the lagoons, he was surprised to see many unusual microorganisms there. We call them stromatolites, and they're so small we can't even see them without a microscope. But they get together and form large communities. In the past, many unusual species lived this way. For example, cyanobacteria. They were important back in their time because they produced oxygen. Earth, in its initial stages, didn't have much of this gas in its atmosphere. The first stromatolites might have been formed by diverse types of bacteria that didn't necessarily produce any oxygen, but were just living their peaceful life there. They formed layers, piling on top of one another, so that at least some of them could get a bit of sunlight. They used sand and sticky liquids to stay close together. Brian was also incredibly surprised because those were the biggest living stromatolites he had ever seen. Living stromatolites usually grow to be over 3.3 feet high, but the newly found ones were 15 feet wide and a few feet tall, which is giant compared to those living in other places. And fossilized ones were even larger. A long time ago, they could grow bigger than today because there weren't many other species that could eat or harm them. Also, there are many other organisms today that can grow faster and more massive than them and take up their space. That's why stromatolites can only survive in rare places where hardly anything else can live, like in these very salty lagoons located high above sea level in Punta de Atacama. The stromatolites found there are the most famous ones because they might be some of the best examples of the earliest life on our planet. But they're not actually the first form of life on Earth. The oldest of their fossils are 3.5 billion years old, while some other evidence we have tells us that life on our planet appeared around 4.1 billion years ago. Maybe some stromatolites lived back then as well. But Earth has changed a lot since then, and the places where they might have lived haven't survived. Now, all this may not seem like a lot at first glance, because no one has found an exotic and weird beast our world has never seen. But these are notable examples of what searching for life somewhere else in the universe might look like. Scientists who are interested in studying Mars often come to this place, since it might be similar to what the red planet looked like an exceptionally long time ago. If there were fossils hidden in the ancient rocks on Mars, they might look like these stromatolites. Another faraway land has revealed some of its secrets. It's Antarctica, with an ancient lost world found under its ice. Antarctica hasn't always been this frosty, isolated land of snow and ice sheets. Once it used to be part of the Gondwana supercontinent, together with what is now South America, Africa, Australia, the Arabian Peninsula, and the Indian subcontinent. But at some point, it split off and went to build a life on its own. It formed as other landmasses started to move away, which created its coastline. But Antarctica was different in many other ways back then too. It used to be a land covered in magnificent forests and rivers full of life. Scientists use radar and satellites to explore a mysterious world hidden under the ice there. This ancient land, which is close to the Indian Ocean, is as big as the U.S. state of Maryland or Belgium. It's more than 14 million years old. Some studies say that this area formed over 34 million years ago, which was way before Antarctica got into its deep freeze. At first, temperatures there were higher, possibly like the weather in Patagonia or the cold, temperate rainforests of Tasmania, New Zealand, or maybe even more tropical than that. But as the climate became cooler, small glaciers started forming on hills close to the rivers. Valleys sunk deeper because of all that ice covering them. And then, temperatures dropped even lower, and a giant layer of ice covered the entire continent, hiding those old glaciers. Rivers shaped this lost world a long time ago, way before it ended up covered in ice that's almost 2 miles thick in some spots. Scientific studies of this area showed that those landscapes had been full of highlands and mountains. The ice that formed over Antarctica made the whole area very cold, so the landscape couldn't erode anymore. This means everything has remained basically the same and untouched under the ice for millions and millions of years. What's interesting is that we know less about this land hidden under the ice than about the surface of Mars. One way to explore it would be to drill through these ice sheets to check for samples of sediments below. They could tell us more about the ancient flora and fauna frozen underneath. It's not a new method. A similar method was used to collect 2-million-year-old samples in Greenland. Australia has a secret world too. Ancient organisms were found hidden in rocks in the northern parts of the continent that are about 1.6 billion years old. These microscopic things are part of a family called eukaryotes. The members of this family that exist today include plants, fungi, animals, and even those tiny organisms with just one cell, such as amoeba. All living things with nuclei in their cells, including us, can trace their family tree back to one of the oldest members of this family. That one is called the last eukaryotic common ancestor, and it lived more than 1.2 billion years ago. Those ancient organisms were more complex and bigger than bacteria. Maybe they were the first predators on Earth, hunting bacteria. Hey, do you believe in folklore telltale signs that can help predict the weather? Actually, many of them even have a scientific backup. So let's dive in. You've probably heard this one at least once. Red sky at night, sailor's delight. Red sky in the morning, sailor's warning. Oh, you haven't? Then you might have heard a variation with the word shepherd instead of sailor. This weather lore was even commemorated by William Shakespeare, I call him Bill, back in 1593. He wrote a poem, Venus and Adonis, and there is a description of the red sky lore. Turns out Bill was right, and this one can be explained. The red sky appears when dust and small particles are trapped in the atmosphere by high pressure. When sunlight passes through the Earth's atmosphere, it splits into different colors of the spectrum and creates colorful skies. If there's a high-pressure system, it can trap dust and vapor in the atmosphere, causing blue light to scatter and leaving only red. So it can indicate that the weather will be clear and calm the next day, whereas a red sky in the morning can indicate a storm is on the way. How about another one with sailors? Rainbow in the morning gives you fair warning. Rainbow at night is a sailor's delight. Now this suggests that if you see a rainbow in the morning, it means that rain is on the way. However, if you see a rainbow at night, it means that the weather will be calm and clear the following day. And the pot of gold at the end of the rainbow is still a myth. Next one. They say no weather is ill if the wind be still. This one's pretty logical too. Calm weather conditions show us that the pressure is high in this area. Highs are regions of descending air, and they prevent bad weather phenomena, such as clouds and precipitation, from forming. But there's more to that. Actually, calm conditions may be a true sign that bad weather's on the way. We often call it the calm before the storm. Have you ever seen this halo around the sun or moon? Well, it's another telltale weather sign. Next time you spot such a halo, make sure to grab an umbrella before you leave the house. This phenomenon occurs because of refraction. The sun and moon provide light, although in different ways, and this light gets refracted by ice crystals at high altitudes. When you see a halo, it means that the moisture up there is going down. Also, these halos may evolve into another beautiful phenomenon, milk sky. The milk sky is still clear, but the typical blue shade is sort of washed away and appears a bit faded or milky. Today, we can just check the weather forecast on our iPhones. But centuries ago, people needed to have some alternatives to be able to predict the weather. The very first weather forecasts appeared around 650 BCE. Back then, the Babylonians would predict weather using cloud patterns. Ooh, that's a fluffy one. Uh-oh, there's a dark one. We should go inside. People had to wait for quite a lot of centuries for mass weather forecasting. The first prototype of what we have today appeared in 1835, and it was thanks to the invention of the electric telegraph. By the way, back in the olden days, animals contributed a lot to weather forecasting. Some traditions are preserved up to today. For instance, Groundhog Day. Long story short, if the groundhog gets out of its den on the 2nd of February in Punxsutawney, Pennsylvania, and sees its shadow, it will go back into the den, and the winter will last for 6 more weeks. On the contrary, if the groundhog does not see its shadow and doesn't get scared, spring will arrive soon this year. There's no actual scientific backup to this tradition, but surprisingly, in most cases, the groundhog predictions come true. Well, in the US, people get predictions from groundhogs. In Croatia and Serbia, people use bears to see if spring's on the way. On the 15th of February, they watch a bear awaken from winter dormancy. It's all about the shadow again. If the bear gets confused when he sees his shadow, it will go back to its den and sleep for 40 more days, thus prolonging the winter. But if it's cloudy on this day, it's a true sign that spring is coming. As to the poor schmuck who has chosen to wake the bear up, I think I'd pass on that honor. Unlike groundhogs and bears, seagulls can help predict bad weather all year round. They say, "Seagull, seagull, sit on the sand. It's never good weather when you're on the land." These birdies tend to sleep on the water, so if they sense turbulent wind, they prefer not to struggle with it but avoid it. Therefore, they just land on the beach and wait. Smart! Rain before 7, clear by 11. Pretty common, but only partly true. The occurrence of late night and early morning rains may be due to the passing of a weather front. Still, it's not 100% correct to assume that morning rain is a sign that the afternoon will be dry. In some cases, a rainstorm that develops in the late afternoon may last up until the night, causing early morning rain. Now, cows could make good weather forecast reporters too. A cow with its tail to the west makes the weather best. A cow with its tail to the east makes the weather least. thing is, they don't really enjoy it when the wind is blowing right in their faces, so they prefer to stand with their backs to the wind. Winds blowing from the west usually bring good weather, and those blowing from the east, on the contrary, are likely to provide unsettled weather. Voila! I told you, cows are cool. So, should you ever be in a pasture with cows, you will know what weather it will be in the next few hours, even if there's no coverage and you can't use your phone. Now, in case there are no cows, bears, or any other animals that are sensitive to the weather, you can use onions. Yep, you heard that right. Even onions can predict the weather, and these guys actually predict long-term conditions. Here's a nice rhyme. Onion skins very thin, mild weather coming in. Onion skins thick and tough, coming winter cold and rough. Well, seems there's no prediction connected to French fried onion rings though. If you want to hear a scientific explanation for this, sorry, there won't be any. In fact, scientists say such rhymes have stood the test of time for one reason only, and it's our human selective memory. We tend to remember things we've predicted correctly, and if not, we just forget them. Oaks and maples can be helpful though, due to their ability to curl leaves when the humidity is very high and the wind's blowing strongly. So, when leaves turn their back, 'tis a sign it's going to rain, turns out to be quite a true saying. There's even a rhyme for it. When the leaves show their undersides, be very sure that rain betides. I know, betides, it's kind of a forced rhyme, but it is a word, it means happens. Okay, time to move on, let's not beat a dead horse, which, by the way, is not a weather predictor. So hey, did you know that you can even use your friends to predict the weather? Our human body is way more multifunctional than you could have imagined. Here's another short rhyme to prove we humans have superpowers. For instance, our body can predict rain. I know ladies by the score whose hair foretells the storm. Long before it begins to pour, their curls take a drooping form. See? I bet you've noticed it many times and maybe even correlated that our hair may act weirdly when the humidity rises. It may expand in length due to humid air, and naturally curly hair may droop. Naturally straight hair, vice versa, may even curl up a bit. If you have blonde hair, you're even more potent at rain forecasting, as it's more sensitive to humidity. On to more precise predictions. Yeah, it's cool to predict the weather, but what about predicting temperature? You can tell the temperature by counting a cricket's chirps. These guys are quite accurate thermometers. When it's warm, they chirp faster. When it's cold, their chirps get slower. Now, here's what you need to do to get the temperature. Count their chirps for 14 seconds, and then add 40 to the resulting number of chirps. Now comes the disclaimer. Crickets only work in Fahrenheit. For Celsius, you'll need to do some extra calculations. While not all weather lures are accurate all the time, they can be a fun way to predict the weather and connect with nature. Meanwhile, my hair is turning frizzy, so I'll grab an umbrella.
Fraser Island sits off the coast of sunny Queensland, Australia. But don't fall for its beauty. It's home to the most dangerous beach in the world. There's nowhere on the island to seek medical attention. If you do run into danger, you're on your own. Dingo attacks are super common here. If you don't know what a dingo is, it looks like an adorable dog. But beware, this wild breed is extremely dangerous. And the dingo's gnashing teeth aren't the only thing to be scared of. The seas around the island are swimming with great white sharks. There's jellyfish in the water too. Fraser Island is home to some of the world's most dangerous kinds, including the Portuguese bluebottle. One sting from its venomous tentacle is enough to take down an adult human. Even if you manage to avoid the creatures on the island, the sea itself is perilous. The waters are incredibly rough and have powerful riptides. These are strong currents that will pull you away from the shore. And remember, there are no lifeguards to come to your rescue if you get in trouble. Even the sand is dangerous. Car rollovers in the thick dunes happen all the time. It's definitely best to swap your car for a dune buggy. Travelers also often drive down the dunes straight into the lakes below, but the lakes are incredibly shallow, which is not very safe. Fraser Island is also known for its beautiful lookout points, but you'll need to watch your step. You might feel on top of the world, but stay well away from the edges as jagged rocks and crashing waves line the shore below. There's an island in Brazil known as Snake Island, which is equally dangerous. I wonder what the hazard could be here. It's home to thousands of golden lancehead vipers, which are one of the most venomous snakes on the planet. They grow to over 20 inches long, and their fast-acting venom melts the flesh from around their bites. There are around 4,000 snakes on the tiny 106-acre isle. Snake Island has become so dangerous that the Brazilian authorities had to ban everyone from going there. For years, the only human inhabitants to brave the island were a lighthouse keeper and his family. But local legend says that one night a group of snakes crawled in through a window to attack, and the family was never seen again. Known as the gas mask town, the island of Miyake-jima is not one to visit in a hurry. It's home to a fiery, active volcano that has erupted several times over the past few years. There were several massive eruptions leading to the spread of a highly poisonous gas across the island. Residents are now required to carry gas masks at all times, and a terrifying alarm blares across the island whenever the poison levels get too high. The island is also in the middle of the Devil's Sea. Ships mysteriously vanish in the area, and experts have no idea why. The North Sentinel Island is home to a remote and unwelcoming tribe. They lived alone on the island without any modern technology or contact with the outside world for over 60,000 years. And that's just the way they like it. They've been known to fire arrows at anyone who attempts to enter the island. There are many stories of people visiting the island, and they are never seen again. It's not ghoulish ghosts or slithering snakes that you have to worry about on the Caribbean island of Saba. It's hurricanes. The tiny island has been hit by more severe hurricanes than anywhere in the world over the last 150 years. There have even been 7 tropical cyclones, which is an intense circular storm. The winds in these storms can reach 254 kilometers an hour. Try standing up in that. You'll also struggle to find a pilot who'll even land on the island. It's incredibly dangerous not because of the winds, but because it's home to the shortest runway in the world. It's only 440 yards long. 2 huge rocky ridges surround the runway, so there's no room for mistakes. The Kilauea beaches of Hawaii used to be one of the most dangerous in the world. The Kilauea volcano has been almost consistently erupting for the past 35 years, spewing red-hot lava into the surrounding waters. The water temperatures have even passed boiling point as a result of the lava. Happily, it's no longer active. While the island of Bikini Atoll might sound like the perfect summer vacation destination, it's most certainly not. The problem is that this place has dangerously high radiation levels, and the locals had to leave it. Although the island was declared safe in the 90s, its original inhabitants have refused to return. The lack of fishing in the area has also led to a massive increase in sharks who swim the waters in search of their next meal. Strangely, the corals and reefs are thriving. From the distance, Ramree Island looks idyllic. White sand, swaying palms. But beware. They say thousands of hungry saltwater crocodiles used to lurk there, ready to strike at any time. The exact number of those animals was unknown, and some scientists claim that there are quite a few of them right now. I'd stay well clear of the island though. I don't really feel like becoming crocodile food. Skeleton Coast in Namibia is appropriately named as the harsh landscape and lack of water make life almost impossible. Whale carcasses, turtle shells, and elephant rib cages litter the shore. If that isn't bad enough, lions and hyenas patrol the beach in search of their next meal. The surrounding waters are just as dangerous, as they are home to 11 different species of shark. Many sailors have become lost on this coast and have never been seen again. Cape Tribulation in Australia also lives up to its name as it is packed, full of dangers. Swimmers have to wear special stinger suits because the water is teeming with stinging jellyfish. Saltwater crocodiles also hide in the water, but they don't make a suit to keep you safe from those. It's not just the jellyfish that sting. The area is covered in stinging trees. The trees have jagged leaves that give the crocs' teeth a run for their money. On land, there's angry cassowary birds. There are flightless birds that are the same size as an ostrich. They have sharp talons that can easily slice through skin. The Outback beach in Norway is one of the best places to see the northern lights, but you'll be lucky if you survive more than one night there. The seas surrounding the island can reach 46 degrees Fahrenheit, and that's just in the summer. It probably feels like swimming in ice cream. For years, Gansby Beach has remained a habitat for the most dangerous creatures on the planet. Sharks are particular fans of its waters, and the coastal stretch is known as the Great White Shark Capital. The sharks are attracted to the 60,000 sea lions that flock to the beach every year. Not just shark food, wild sea lions can be unpredictable and aggressive towards humans. Comoro Islands are the worst vacation destination for those who don't really like mosquitoes. The place is swarming with the little guys. Locals say all the water on the island must be contaminated because of them. So they like to sterilize water before drinking, making ice, and even brushing their teeth. If you're really into coconuts, there's one place you should probably go to grab some. I'm talking Danger Island. Yep, it's the real name of one of the islands in the Chagos archipelago. It shouldn't scare you off though. The major problem it has is parking. I mean, safe anchorage for those who come there. Finally, while it may sound dreamy, you're probably going to want to avoid the beaches of the Amazon. Sharp-toothed red-bellied piranhas, anacondas, and electric eels are just some of the beach's regular residents. It has one of the widest varieties of animal species on the planet, including the Amazonian giant centipede, which has a poisonous bite. It's not just the animals of the Amazon that you have to watch out for. Strychnos and curare are the two Amazonian plants that are super poisonous.
Ah, beautiful! You're walking with your friend and look up at the sky. The sun looks a bit different today, like it has some kind of ring around it, a rainbow type thing. Huh? Hey, look at that! Your friend pulls his head up out of his phone. You shouldn't look directly into the… Stop everything, he says. It's a sun halo. We need to find shelter now, unless you have the world's biggest umbrella on you. A sun's halo is nature's sign that there's a snow or rainstorm on its way. It's caused by clouds that are made of bazillions of small ice crystals flying around 20,000 feet. Sunlight goes through those crystals, which causes the light to split and refract, like when there's a rainbow. Now, don't look at the sun halo directly. It's going to be tempting because it's not something you see every day. Plus, it's really beautiful. But ultraviolet light can burn the exposed tissue of your retina and cause serious damage. So, not worth it. Grab some sunglasses and you're good to go. This phenomenon lasts about 40 minutes. These clouds are the same ones that can cause a spooky ring around the moon at night sometimes. Nature sends early signs of disasters in many ways. J-shaped trees means there's a landslide coming. Since the ground is moving slowly, the trees grow into the super selfiable shape. Try to find a flat area and avoid going near any trees, unless you have superhuman strength. You're on a nice walk on the beach. Sand, sun, not a cloud in the sky. Then, out of nowhere, you see the ocean going back away from the shore. Suddenly, you can even see bits of coral, small fish, and other random small sea animals. That's a good sign to leave. There might be a tsunami on the way. A tsunami is formed when there's an earthquake underwater, and it can hit the coast at 500 miles per hour. It's mostly a Pacific Ocean thing, but why risk it? If there's a channel of choppy water on the beach, stay away. There might be a rip current under the surface that can be extremely dangerous. Sometimes waves hit the shore in a weird way, which forms these rip currents. You might see a strange gap in the waves, or you might notice random bits of seaweed going in all different directions. If you don't ever find yourself caught in a rip current, try to stay afloat and don't waste your energy swimming against the current. Yell out for help and try to float your way along the beach. Once you break out of the channel, swim diagonally to the shore. If you find yourself in the ocean and see a group of sharks swimming, okay, this scenario doesn't sound good either way. Well, the good news is they're not necessarily coming for you. The bad news? The sharks might be trying to escape from a huge tropical storm or even a hurricane. Sharks can sense these things, so when nature gets angry, they group together and swim deep under the surface to get to safety. You probably shouldn't follow them. Good luck! The golden rule since ancient times: follow the animals. Insects, rats, and snakes leave their homes a couple of days before really big earthquakes. Scientists can't track or really explain how they know it's coming. It seems animals really can sense earthquakes, maybe because they feel those smaller initial shock waves that we don't even notice. What if you see animals running towards you? Well, that could mean you're about to get eaten for breakfast. Or it means there's a wildfire behind them. Amphibians like frogs, toads, and salamanders try to protect themselves by burrowing down into the ground. Others just run. Before you start running alongside them, check to see if you can see smoke. You don't want to sprint flat out for nothing. Well, it's not just animals. We can spot warning signs too. For example, if you notice your hair suddenly starts to stand on end and your jewelry starts to buzz, take shelter right away. Lightning might be about to strike somewhere nearby. If you're outside and can't run into a house, make sure not to stand near any tall structures. Lie flat on the ground. Be near water. Seek shelter under an isolated tree or stand in an open space. And don't stand on top of the Empire State Building. That thing gets zapped hundreds of times a year. Do you like skiing? It's all fun and games until all you can see is white. Avalanches can move up to 80 miles an hour, so watch for some warning signs. Does it feel hollow when you walk in the snow? Are there cracks around your feet? Can you see a huge avalanche coming? Time to go! Sometimes a storm mixes its blue light with the red light from the sun, and you get a pretty impressive green. Enjoy it from a safe distance, preferably indoors. This super tall thundercloud usually means you're about to get smashed by hail, or worse, a tornado. Find cover somewhere, like in an underground parking lot or a basement. It might be a bit embarrassing if you're wrong, though. Okay, we know volcanoes can be dangerous, but the lakes near them? Is anything not a sign of danger? Lakes that are near something boiling hot that never cools, so volcanoes, are like wildly shaken soda cans, just about to burst. The magma that's underground actually pushes carbon dioxide into the bottom of the lake, and that gas stays there, waiting. Then, even something boring like rain can disturb the lake a little too much and bam, or boom! You get the picture. Diving, swimming, snorkeling, the sea can be amazing, but it's pretty unpredictable. When two wave currents run into each other, they can create a cross sea. It looks pretty cool from far away, but it can be really dangerous for swimmers, surfers, or even ships. There's a strong current roaming around under the surface. You're walking on the beach, apparently every good story starts like this, and all of a sudden, ooh, a cave. How cool is this? You should probably go in there, explore a bit, and no. If there's a full moon out, you might not be able to get out of that cave. A full moon affects the tide and makes it lower than usual. That cave might be more accessible, but instead of an exciting adventure, you could end up trapped in there until the next full moon. Bring a big lunch. A wall cloud is one of those things you're both excited and scared to see. Scared because you don't know what it is. Excited because, well, how often do you see something like that? Whatever you feel, tell your legs to start running. During a thunderstorm, these wall clouds sit lower than anything else and can be up to 5 miles long. And if they start spinning, well, Dorothy ended up in Oz. Who knows where you'll end up? It's 2009 in Italy. A man was hanging out in his kitchen. Then he saw some flickering lights. He knew just what to do. He moved his family to a safe place. A couple of seconds later, a massive earthquake hit the whole region. His family survived thanks to his quick reaction. He knew these flickering lights were actually a sign of an upcoming earthquake. People have been seeing these mysterious lights for ages. Some thought it was some kind of sign coming from space. Scientists never used to take them seriously, but after the invention of photography, more and more evidence of these strange lights appeared. Soon, they realized the connection. The lights appear, and pretty soon, the earthquake hits. After a bit of digging around, they actually found some records of these earthquake lights from hundreds of years ago. There were bluish flames coming out of the ground right before an earthquake. Ooh, creepy. Oh, ocean, come on, not you again. Okay, but just one more. If you see the oceans turned all reddish-brown, don't go in the water or anywhere near it. This red tide is caused by toxic algae and is something you can find all over the world. That toxic algae can be there even if the ocean's a normal color. Getting that stuff all over you can cause some health issues. Rinse yourself off in fresh water as fast as you can. You know, they even wrote a holiday song about it. Algae Home for Christmas. No, really.
You're walking along a hot desert under the scorching sun. You run out of supplies. There's no more water. You dream about rain, but there are no clouds in the sky. With each step, you lose more and more strength and fall. You notice a small pond nearby. Is it real water or just a mirage? You can't get to your feet, so you crawl there. The water is getting closer by the minute, but not because you're moving towards it. It's the water approaching you. In a few minutes, the pond area increases. Here, you're already in it. A small lake is formed, 60 feet deep, at the place where the piece of desert was. This real event happened in 2014 in the Tunisian desert. No one knows exactly on what day the lake appeared, since this part of the south of Tunisia is sparsely populated. At first, shepherds passing by saw the lake and didn't believe their eyes. In the next few hours, hundreds of locals came running to the place. They began to swim, jumping into the water from the surrounding rocks. But a few days later, something strange happened to the lake. In the beginning, it was a crystal clear turquoise blue color, but then it turned dark green. People didn't attach any importance to this and continued to swim. They shouldn't have done that. The scientists and geologists arrived and immediately announced that it wasn't safe to swim in the lake. Muddy green water means the lake is stagnating. It's not refreshed, it's not fed by underground springs. Now the lake is filled with algae and a lot of harmful bacteria that can cause serious diseases. They also found out that this region of Tunisia is filled with huge deposits of phosphate. This substance can disintegrate and leave radioactive traces. The lake can be carcinogenic, toxic, and hazardous for any living organism. But people didn't worry about this too much. They walk in the middle of the desert, while the sun heats the air to 104 degrees Fahrenheit. Most of them are unlikely to refuse to jump into cool water, despite the warnings of scientists. Until now, no one knows exactly the reason for the appearance of the lake. Some scientists believe the lake was formed because of heavy rains. The lake is surrounded by rocks and is located inside a canyon. The water could just accumulate after each storm. Some geologists think an earthquake was the cause of the lake. A small seismic activity provoked the rupture of the Earth's rock above the water table, and through this hole, all the water splashed out. And if this theory is correct, then the lake can be pulled back underground through cracks. This is the same as when you pull the plug out of a drain hole in a filled bathtub. Any small earthquake is like pulling the plug out. Therefore, if you find yourself in these places, don't swim in this radioactive lake. We're going to the Caribbean Islands region. Among the clear blue sea, you can find a unique lake. It's located on one of the paradisiacal islands. You may not even notice the lake right away. The entire territory may seem like a huge concrete platform, but the main thing is not to step on its surface. Pitch Lake is a lake filled not with water, but with liquid asphalt. This is the largest asphalt deposit in the world. Steam is coming from all over the lake as it's hot. The depth of this lake is 250 feet. An entire passenger Boeing could fit there in an upright position. The lake is not fully studied, but scientists believe there's a deep fault in the Earth's crust under it. A huge amount of oil seeps through it. It passes through various chemical compounds and turns it into the asphalt. According to rough estimates, there are about 10 million tons of hot material inside this place. Theoretically, no life can exist in such conditions, but scientists have discovered a colony of microbes. Somehow, these creatures have learned to survive here. This also suggests that life outside of our planet may exist. The largest moon of Saturn, Titan, has many hydrocarbon lakes on the surface. And if the simplest forms of life appeared among a million tons of molten asphalt here on Earth, then nothing prevents them from appearing on Titan. We're going to Indonesia, to the island of Java. You need to climb a large volcano to see the next phenomenon. The volcano is overgrown with grass and trees, but it doesn't seem to be sleeping. Smoke is pouring out of its mouth. You climb to the top and see a clear lake instead of boiling magma. The blue sky is reflected in its bright turquoise surface. But don't try to jump there. This lake is filled with acid. The magma inside volcanoes comes from the deep bowels of the Earth's crust. The incandescent liquid consists of many molten metals and chemical compounds, and the lake is filled with particles of these metals. In addition, the volcano emits sulfur dioxide gases. When they combine with metals, they form a beautiful turquoise color. You'd better come back here at night. In some places, a lot of sulfur is concentrated. These accumulations come out of the lake and come into contact with the air. When this happens, everything around bursts into bright blue flame. It's safe to observe this from the side, but don't get too close. Nearby, on this island, there's another acid lake. It also releases sulfurous gases into the air, which are easily ignited when in contact with oxygen. And when this happens, the gases burst into a bright blue electric flame. It's difficult to see the flames during the day. At night, you can see these flashes from afar. Our next location is Australia. You start the drone high above the forest area. Among the green dense forests, you can see a bright pink spot. It's our lake. This time, the beautiful pink color may not stop you from swimming. You can relax here and take beautiful photos. The lake attracts thousands of tourists, but scientists have only recently been able to find out the reason for the unusual color. At the bottom of this salty lake in Melbourne, special algae grow and secrete a red pigment. In combination with sunlight, high temperatures, and a small amount of precipitation, it turns the lake pink. By the way, Australia is not the only place with such a phenomenon. There are lakes with a pink tinge of water all over the world. You can find them in Senegal, Bolivia, Kenya, and many other countries. The water of these places is also salty and contains the red pigment of unusual algae. We leave the hot beaches and fly to cold Canada. Here, we see a frozen Lake Abraham. We step on the ice and notice huge frozen bubbles inside. They resemble jellyfish, and there are thousands of them there. This is methane. It's a highly flammable substance. The grass, leaves, pieces of trees, and any organic substances that fall into the lake become food for a lot of bacteria that emit methane. Upon contact with frozen water, methane turns into tens of thousands of frozen balls. When the ice melts, the bubbles burst and sizzle. This phenomenon can also be observed on some shores of the Arctic Ocean. There, the size of the bubbles can reach several times more than balloons. It's a beautiful sight, but it's not safe since methane ignites when it contacts with air. We're in the coldest place of our journey. It's Antarctica, near the driest desert on Earth. A dry place doesn't mean it has to be hot. It's an area with minimum precipitation. The desert isn't sand and cacti, but a place where almost no living life inhabits. Some areas of Antarctica meet these two criteria. However, in this icy desert, you can notice a tiny lake. Its depth is only a few inches. Technically, it's a pond, but the most amazing thing is that it stays in a liquid form. The temperature here drops to -58 degrees Fahrenheit. The pond should be frozen, but this doesn't happen. Don Juan Pond is one of the saltiest reservoirs on the planet. The amount of salt here doesn't allow the water to freeze. Scientists have been studying this lake for more than 60 years, but they still can't find out the exact reason for the appearance of water here.
It may seem that today, with our quite advanced technological development, science can explain pretty much any natural phenomenon. But that's not always true. Some things still stump experts and make them build exotic theories. Let's have a look at some of such phenomena. Hessdalen lights are a puzzling phenomenon you can observe in Hessdalen Valley in central Norway. The thing is that some highly unusual lights can often be seen over the valley. They appear mostly at night. The lights are typically white, but they occasionally turn yellowish or reddish. Nobody knows what makes them change color. What's more, the lights can move. And if at one moment they seem to motionlessly hang in midair, the next minute they may travel somewhere at lightning speed. There's no certain place where they appear, and you can't predict the duration of their stay. Despite all the research that has been done since the 1980s, scientists are still unable to explain this phenomenon as well as such weird behavior of lights. The sardine run lasts from May to July. During this time, millions of sardines swim northward along South Africa's east coast. You can probably imagine a feeding frenzy that starts at that time. It's believed that the water temperature must get lower than 70 degrees Fahrenheit for the migration to begin. This mushroom with a difficult name, Corioactis gister, is only found in Japan and Texas, and it makes scientists extremely confused. Why these two locations? It's true that they're on the same latitude, but these places are definitely not the only ones. Plus, they're so far away from each other. After studying the mushroom's DNA in 2004, experts suggested that the two populations might have been separated into two lineages around 19 million years ago. On Central Flores Island, there's a 3,000-foot-high volcano called Kelimutu. At its base, there is a small town. If you want to see the main attraction of the area, you'll most definitely stay there. And the attraction I'm talking about is 3 lakes, known as the Lake of Old People, the Lake of Young Men and Maidens, and the Enchanted Lake. Why are these lakes so popular and attract so many people? They inexplicably change colors. Ancient legends claim that the lakes are the final resting place of human souls, and those souls stay in different lakes according to their actions. As for scientific research, no one has yet conducted any to discover the cause of the changing colors. But theorists suppose that it might be due to underwater volcanic activity. It might be pushing minerals to the lake's surface. Then, depending on what elements those are, the lakes can turn blood red, bright turquoise, or olive green. But the coolest thing? The lakes are never all the same color at the same time. This phenomenon is unique and hasn't been observed anywhere else in the world. Those who have ever heard an annoying noise a kettle makes to inform you the water inside is boiling can imagine what the whistle sounds like. Even though this noise isn't as blood-curdling as some other unexplained sounds, it doesn't make the whistle any less mysterious. It's incredibly elusive. In 1997, only one underwater microphone was able to pick it up. At that time, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the unusual sound is an eruption of one of the submarine volcanoes. But once again, there's not enough proof to make sure. There's probably no person on Earth who doesn't marvel at the mystery of the Bermuda Triangle. But not everyone knows that there is another triangle. Not so famous, but just as dangerous. Dragon's Triangle, or the Devil's Sea, lies in the area between Japan and the islands of Bonin. It covers a big part of the Philippine Sea as well. That's why people also call this place the Pacific Bermuda Triangle. Surprisingly, or not really, the Devil's Sea is situated exactly opposite the Bermuda Triangle. Ships and planes tend to disappear here with the same regularity as in the North Atlantic Triangle. People also report seeing ghost ships in the open sea. And while scientists provide logical reasons for the vanishing vessels and aircraft, most people still believe in the paranormal nature of Dragon's Triangle. For the first time, a bizarre sound later called the upsweep was registered in 1991 in the Pacific Ocean. One of the most unusual things about the sound is that it's constantly changing. It varies from high to low frequencies and then back again. You can hear it better in the spring and fall than in the winter and summer. The sound travels from the bottom of the ocean toward its surface. Scientists do have a theory explaining this phenomenon. They think it might be the activity of undersea volcanoes that causes the sound. Hot lava that's pouring into the ice-cold ocean water can theoretically produce such noise. But researchers haven't found any evidence to confirm this theory yet. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Potomsky Crater is described as a mount with a perfect shape. Its size is more than that of a 25-story building. It sits in the middle of the woods with its top chopped off and presents quite a sight. In fact, the shape of the crater is pretty unusual. It has a rounded inner dome that is about 40 feet high. At first sight, this formation looks like a volcano, but after a closer examination, you might realize that it's not the case. The dome in the center of the cone is extremely unusual for a volcano. In addition, there haven't been any volcanoes in this region for millions of years, while the age of the crater is estimated to be about 250 years. The weird shape that the crater has is like nothing scientists have ever seen. This, as well as the fact that any theory fails to explain the origin of the formation, adds to the mystery around it. And that's not the most terrifying thing. After researchers analyzed the growth rings of the trees near the crater, they found out that the trees experienced a period of strangely accelerated growth that lasted for 40 years. After that, they began to grow as they were supposed to. The level of radiation near the crater is also higher than in the nearby areas. No one has an explanation for this fact. On top of that, nothing grows on the blood-chilling formation. Perhaps because the crater also has a lovely habit of constant shifting. It rises and falls, influenced by some inexplicable force. Locals believe in the evil that dwells in that place. While exploring the Amazon rainforest, researchers discovered gigantic geoglyphs. They're geometrical drawings carved into the ground. The trenches were as large as 36 feet wide and 13 feet deep. They were created at different times, most between the 1st to the 15th century. There are more than 450 geoglyphs in the north of Bolivia and Brazil. The most ancient of them could have been created around 3,000 years ago. The huge earthworks were likely used for common meetings and discussions, but scientists haven't found enough proof yet.
Hey there! Imagine a place on Earth that's just like Venus. It's Chile's Atacama Desert. I assume you wouldn't want to spend your holidays there. Similar to other deserts, this one isn't exactly the friendliest place. It's a long stretch of land close to the Andes Mountains. This makes it one of the driest spots on the planet. In fact, It's so dry that only a few places in Antarctica have stayed without rain for longer. This tough environment has some benefits to offer. Because it's located high up and doesn't have many clouds or a lot of light pollution, it's become the perfect home for advanced telescopes. These telescopes help us explore the cosmos. A new study from June 2023 revealed that this desert is even weirder and more out of this world than we had thought. It makes sense that a desert as dry as this one gets a lot of sun. On average, it has about 308 watts of sunlight per 10 square feet. That's almost twice as much as places like Europe or the eastern United States get. Raul Cordero is a scientist. He and his team checked out the sunlight in the spot housing the biggest telescope project ever, the Atacama Large Millimeter Array. And this is the sunniest place on Earth. This is what you'd experience if you were about 79% of the way from the sun to Earth. Of course, if you were actually on Venus, you would have way bigger things to worry about than just a lot of sunlight. Now let's figure out why this place is almost as sunny as Venus. It's because of clouds. Usually, clouds block sunlight and keep us cool, but sometimes they can act like a magnifying glass in special situations, concentrating the sun's rays. This is called forward scattering. This happens when certain types of clouds show up during the South American monsoon in the middle of the summer. During the summer in the southern hemisphere, we're actually a bit closer to the sun, and there's less ozone in that part of the world. This combo might explain why other high places on Earth, like the Himalayas, don't get as much intense sunlight as this desert. Let's talk more about Venus. What would it be like to stand on the surface of this planet? The more you learn about this sweltering world, the less you want to picture yourself there. It's not a friendly place at all, with crazy heat and super heavy air that could crush you. But pretend for a moment that you're on Venus. The air there is thick and heavy, 93 times denser than what we have on Earth. The air presses you down. Think of having a small car resting on your thumbnail. That's how it would feel. Or think about diving really deep into the ocean. You'd feel a lot of pressure pushing on your body. But on Venus, it's like having all the pressure of the atmosphere squishing and almost flattening you. What is the weather like on Venus? Ouch! Heat. Even though Mercury is closer to the sun, Venus wins the prize for the hottest planet's surface. That thick air on Venus is mostly carbon dioxide, which acts like a blanket. When the sun shines on Venus, the heat gets trapped by this blanket of air, and the planet heats a lot. Temperatures on Venus can hit 860 degrees Fahrenheit. Now, how do we explore Venus without getting roasted or squished? Well, going there in person is a no-go. Robots can handle it, yet even robots have struggled on Venus. Only a handful have made it to the surface. And they only managed to survive for a few hours before getting wrecked by the harsh conditions. The good news is we're figuring out ways to study Venus without putting anyone at risk. Future missions will check Venus out from above. Spacecraft up there will be able to see through the atmosphere without any trouble. NASA's got the Veritas mission. Its aim is to make detailed maps of Venus from orbit, giving us a new view of the place. So we've examined the driest desert on our planet, the Atacama Desert. No wonder this area is the place that serves as testing grounds for space missions. But despite how arid this region is, there is life there. This is a realm of flamingos and lagoons. The place has colossal salt flats that extend for 4,633 square miles at a depth of 82 feet. It's a place of erupting geysers, naturally heated springs, towering volcanoes, herds of llamas, and deserts so parched that certain pockets have remained untouched by rain for over half a millennium. All this unfolds 2 to 3 miles above the sea level. What else survives in the Atacama Desert? It's quite hard to fathom that plants could thrive in such inhospitable conditions. Yet, they manage to survive here. Take, for instance, Tillandsia landbecki. These plants defy the odds in the desert by extracting moisture from the fog that rolls in from the nearby coast. This fog water can also serve as a sustainable water source for humans. These plants lack traditional roots. Instead, they use their older, deceased parts to anchor themselves in the sand, forming little dune-like structures. They draw moisture out of the mist through their slender leaves and shoots, which swell upon contact with water. Nocturnal dew also provides water, particularly during the summer when fog is scarce. Together, plant communities existing there are known as lomas vegetation. The presence of this vegetation in the Atacama Desert is limited to a narrow coastal area where fog regularly occurs. Factors such as the distance from the Pacific, prevailing wind direction, and topography restrict the distribution of fog ecosystems. Satellite data analysis reveals that plants grow at altitudes ranging from 2,625 feet to 4,100 feet above sea level and up to 28 miles inland. They are mainly found on sandy plains along fog corridors or on slopes. They're about as tall as 1.5 feet, and they usually form a line. This clever lineup helps them catch all the moisture and yummy nutrients they need. The arrangement of these clusters depends on how much foggy water they can find. These tough desert plants are like water wizards of the plant world. They're so good at surviving in the desert that they give us ideas about getting water from fog. Water is precious in places like Iquique and small villages near the desert. Plus, with all the digging for stuff like copper and lithium, which makes batteries work, they need even more water. Usually, people get drinking water from under the ground, but these little plants have something to teach us. Using this trick, we're making a map showing where these plants like to party most. This map could help us find perfect spots for catching fog with special nets. Here's another idea that will make you feel like you're on the surface of another planet. Pelican Point is in Namibia. You might not expect it, but Pelican Point is actually a great place to surf. Every year, it only gets around 0.30 inches of rain, but that doesn't stop surfers from riding the waves. The weather is kind of unique here. It's hardly ever too hot or too cold. This place has an unusual type of dry climate, thanks to the cold ocean currents near the bay. Skeleton Bay, alternatively named Donkey Bay, is an iconic surfing location. The surf wave crashes onto the sands of Pelican Point, situated about 5 miles northwest of Walvis Bay, a compact harbor town famous for its sand dunes and secure anchorage. Would you surf there?
Imagine sitting at home, drinking coffee, and watching a new episode of your favorite series. And suddenly, boom, crash! What's happened? Nothing terrible, just a meteorite that has just crashed into your kitchen after breaking the roof. You might think this story is entirely made up. But that's what actually happened in New Jersey during the Eta Aquarid meteor shower, which is active from April 19th to May 28th and peaking on May 5th through 6th. The space rock itself was the size of a pork roll sandwich. It was also pitch black and weighed almost 4 pounds. It slammed through the roof and hit the wooden floor, ruining it. When the inhabitants of the house found the rock and touched it, it was still warm. Luckily, the thing wasn't radioactive and there was no one at home at the time this intruder arrived. But the most shocking thing about this meteorite? Astronomers believe it might have come from a cosmic snowball traveling far, far away from Earth. To explain this, I'll have to tell you a bit more about the Eta Aquarid. This meteor shower is famous for its fast meteors, leaving long, glowing trails. It's produced by Comet Halley, completing its orbit around the Sun every 76 years. The comet hasn't visited Earth since 1986 and won't come back until 2061. Right now, it's somewhere near the constellation of Hydra, which is more than 100 light-years away from our planet. Every year, Earth has to pass through trails of debris left by the comet. They collide with our atmosphere, disintegrate, and create beautiful, colorful streaks in the night sky. And it happens every time Halley returns to the inner solar system. Its nucleus sheds a layer of ice and rock into space, and some of it reaches our planet. The Central New Jersey authorities believe the meteorite that sneaked into the house originated from that meteor shower. But I feel that you might be pondering another question that confuses many people. What's the difference between all those space bodies? I mean, there are so many of them flying out there. Meteors, meteorites, asteroids, comets. Ugh. Okay, let's figure it out together. An asteroid is a rocky body orbiting the sun. It's usually not very big and quite inactive. Comets are different. They're covered with ice that normally evaporates in sunlight, forming a coma, which is what a comet's atmosphere is called. This coma consists of dust and gas. A comet also has a tail that is made of dust and/or gas too. A meteoroid is a small part of a comet or asteroid that orbits the sun. If this meteoroid manages to sneak into Earth's atmosphere and vaporize there, it's a meteor. It's often called a shooting star. And finally, if a meteoroid manages to survive the passage through our planet's atmosphere and lands on Earth's surface, it becomes a meteorite. If you think such space guests are a rare occurrence, that's not exactly true. Every day our planet is hit with more than 100 tons of sand-sized particles. About once a year, a large, car-sized asteroid enters Earth's atmosphere, turns into an impressive fireball and burns, luckily, before reaching the surface of the planet. And every 2,000 years or so, a meteoroid the size of a soccer field hits Earth, causing a lot of damage. And now, imagine this. A huge, really ginormous asteroid is approaching our planet. There's no one on Earth to predict its appearance. Neither is there anyone to stop it. That's why soon, the asteroid crashes into the surface of Earth. The force of the collision is so powerful that the space visitor doesn't stop until it gets through the crust to a depth of several miles. The impact leaves a crater of more than 100 miles across. Thousands of cubic miles of solid rock instantly turn into vapor. The crash sets off a series of natural disasters that erase 75% of life on Earth. The creatures that were close enough to see the crash don't survive for longer than a few seconds. Even closer to the impact crater, the ground is covered with thousands of feet of hot ash, grit, and rubble. Several seconds later, everything for many miles around bursts into flames. What doesn't burn down within the next several minutes after the collision faces a different, even more terrifying fate. The asteroid causes a monstrous, largest ever tsunami. A recent study claims that it was thousands of times more powerful than any wave people have ever seen. The tsunami was so devastating, it eroded seafloor sediments half a world away. The team of scientists even remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the one in the Indian Ocean in 2004. You've probably already guessed that I'm talking about a real-life event, namely the asteroid collision that wiped dinosaurs off the face of the Earth. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. The impact was so powerful that it left its signature on the face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. But such devastating events, when an object that large threatens Earth's inhabitants, happen very rarely, once every few million years. Space rocks smaller than 80 feet usually burn up in the atmosphere of our planet, causing little to no damage. If a rocky meteoroid larger than 80 feet but smaller than half a mile across was to hit Earth, it would cause local damage to the impact area. As for a space rock with a diameter larger than half a mile, it'd likely have worldwide effects. And these space bodies aren't even the largest. For comparison, asteroids populating the main asteroid belt between Mars and Jupiter can be as huge as 580 miles across. But you can breathe out. They're too far away, and don't pose any threat to our planet. All the time, our scientists keep learning more and more about hazardous asteroids and comets. They have even established a Planetary Defense Coordination Office, aka PDCO. It ensures that potentially hazardous objects get detected as early as possible. An object is considered potentially hazardous if its orbit is predicted to bring it within 5 million miles of Earth. It should also be large enough to reach the surface of our planet, over 100 feet across. Interestingly, a meteorite impact isn't the worst thing you need to worry about. Some scientists warn that the most dangerous thing is the shock wave produced by a meteor breaking apart in the atmosphere. For example, one meteor, which originally was an asteroid the size of a 6-story building, entered our planet's atmosphere in February 2013 and broke apart 15 miles above the ground. This generated a shock wave that was equivalent to a ginormous explosion. An even larger space visitor was called the Tunguska meteorite. It was also 10 times more energetic. It broke into pieces over the Tunguska River in June 1908, flattening 500,000 acres of forest. If the meteorite hadn't been so huge, this event would have gone undetected because of the remote location where it all happened. So it's a good thing that 90 to 95% of meteors don't survive the fall through our planet's atmosphere. Only those that are made of stronger materials make it so far. Most meteorites, though, are thought to come from comets, which are way more fragile than asteroids. We should also consider the speed of a meteor. If one is approaching Earth at a slower speed, it's more likely to survive the collision with the atmosphere of our planet. It means that the meteor won't burn completely, and some of its remains will reach the ground.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink sea water. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents and started the amazing adventure of the evolution of life on our planet. My, it's wet out here. In 2016, scientists decided to study the widest part of the Atlantic Ocean between Africa and South America. It's kind of lonely there. They went days without seeing a single plane or ship. It was mostly just dolphins and whales swimming by. They were in the middle of nowhere. So why? They were floating right above one of the most important geological spots on Earth, the Mid-Atlantic Ridge. It's where two monster tectonic plates meet. Tectonic plates are massive jigsaw pieces that are constantly moving, even though we usually can't feel them. They form the Earth's crust and, in this case, meet beneath the Atlantic Ocean. The researchers floated over the ridge and dropped down some instruments that detect waves, earthquakes, and other vibrations. A year later, they came back to collect the results. At first, the goal was to learn more about the history of the two plates. But the instruments picked up a whole lot more than that. They found out some stuff about the future, too. Way down at the bottom, there's a layer of extremely hot liquid rock that's constantly rising up, pushing on the tectonic plates and causing them to move apart from each other. That means that the Atlantic Ocean is expanding about 2 inches every year, pushing Europe and Africa away from the Americas. At the same time, its bigger neighbor, the Pacific Ocean, is shrinking. It's the biggest ocean, right now, with a huge area that's around 30% of the Earth's surface. Its average depth is 13,000 feet and is home to the famous Mariana Trench, the deepest spot in any ocean. And yeah, it's now shrinking by around 1/5 of a square mile per year. Some scientists even believe that eventually, millions and millions of years from now, the Pacific Ocean could completely disappear. This ocean is where we think most earthquakes happen, plus it's where a lot of the world's volcanoes are. All that causes lots of shaking. Plates move around and old parts of the Earth's crust get destroyed. The ocean floor can't grow fast enough to replace it. This means some big changes are coming in the future. A couple of inches isn't exactly a big deal, but after a few 100 million years, there'll probably be a new supercontinent on Earth. Australia is slowly heading north, and it could eventually collide with Korea, Japan, and eastern China. Africa is moving too. In 50 million years, it'll be pushing right up against the southern parts of Europe. Since it's all happening so slowly, I've had a chance to think up some future scenarios. Okay, not me. A bunch of super brainy scientists with even brainier computers. The first scenario, a monster landmass called Novo. The Americas would slam into Antarctica, then they'd team up and head over to Africa. Meanwhile, Africa would have already smashed into Europe and Asia. Not bad, at least you'd save some money on plane tickets. But for most people, it would take an epic road trip to get to a beach somewhere. The second scenario is Ultima. I feel like these all sound like car names. Anyway, in this scenario, the Atlantic stops getting wider. Actually, it's the opposite. It starts closing in on itself. This new super cool continent would be surrounded by the Pacific Ocean. Scenario 3. Orica. Both the Atlantic and Pacific Oceans eventually shrink down until they either disappear or end up like tiny little lakes. All the life in these two oceans is gone. Instead, some new ocean starts forming to replace them. And the new supercontinent? It has Australia in the corner, with the Americans and East Asia each on the opposite side of a small puddle that used to be the Pacific. The rest of the planet is one big unexplored super ocean inhabited by… who knows? I won't be around then. Number 4. Amasia. There's that car thing again. This one predicts Africa, Australia, and all the continents except Antarctica start moving north. Sorry, Antarctica, even planet Earth keeps forgetting about you. Better luck next time. Well, way off in the future, it might be possible to take a big old road trip across every continent, or drive across the African-South American border, or even get to Australia without having to take the longest flight of your life. But we've got a while to wait. What should I do for the next 250 million years? Binge watch some Brightside? Tectonic plates move at different speeds, some slower, some slightly faster. Your hair and fingernails actually grow at roughly the same speed as these beasts move. Imagine if everyone lived on one of those supercontinents. Animals would finally be able to cross continents and meet species they've never seen before. Leopards, rhinos, lions, elephants. Imagine if they got curious enough to set out on a journey out of their habitat. A lion might meet a polar bear. Kangaroos could finally leave the land down under, and birds that migrate to warmer places would have to totally reorganize their travel schedules. Who knows what the climate would be like? Playing around with the continental jigsaw puzzle isn't exactly a new thing. Our world didn't always look like this. 300 million years ago, our planet didn't have 7 continents. It had only one, a supercontinent called Pangaea. Pangaea was surrounded by only one ocean. Over time, it slowly started falling apart. At one point, South America, Antarctica, Australia, and Africa were one unit, and North America and Eurasia were another. Over time, these continents also splintered off, each heading in its own direction. Scientists have discovered many similar plants and animal fossils on continents that are separated by huge oceans. Even when you just glance at a map, you can see how Africa and South America look like two massive puzzle pieces that fit together perfectly. When you look at all the oceans and seas on a map, it may look like they just flow right into each other, like there's only one big ocean and people gave different names to different parts. You wouldn't think that if you've ever been to the place where they meet. The Atlantic and Pacific have a strict border that looks like an invisible wall separating two completely different worlds. You can clearly see different colors and waters, and they don't mix. Of course, there's no wall or any actual physical border, but not all water's the same. The Pacific and Atlantic have different densities, amounts of salt, temperatures, and a whole bunch of differences. The borders that separate two bodies of water are called ocean clines. The line you see dividing the Atlantic and Pacific Ocean is mostly caused by different salt levels. This is what layers of water with different salt levels look like. It's like they're separated with cling film, each one with a different color because it has different things growing in it. To see a clear, noticeable border, one sea or ocean has to be a whole lot saltier than the other. Want to get active and use up all the salt in your house? Pour some colored salty water or seawater into a glass bowl. Then add fresh water on top. Voila! The Pacific Ocean is the less salty one. That's because there are loads more rivers flowing into it. Heavier liquids are heavy, so they should sink to the bottom. But then, why is the border between the Atlantic and Pacific a vertical line and not a horizontal one? First, the difference in density of these two salty beasts may be enough to stop them from mixing, but it's not really enough to send one of them to the bottom with the other floating above it. There's another reason, and it's all about the Earth spinning around. Say you're flying from Chile to New England. If you fly straight north, by the time you get there, the Earth will have turned a bit, and you'd be nowhere near your destination. To get to the right place, the pilot needs to fly in a bit of a curve. That's sort of the same reason that currents move around in different directions. The currents in the Atlantic and Pacific Oceans move away from each other, so they don't really mix at their border, even though they're both just water. Confused? Yeah, me too. Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campiflagre, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campiflagre erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campiflagre has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campiflagre is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817, as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
Imagine standing in the middle of Europe 40,000 years ago. The landscape is rough, cold, and unforgiving. Fast food is scarce, and there's no internet. Suddenly, from out of the woods steps a figure, stocky, strong, and with a face that is quite unusual. This human looks similar to us, but something about them is different. Their brow is heavy, their nose is broad, and their body seems to be built to fight nature itself. Well, congrats! You've just met a Neanderthal. You might have thought that Neanderthals were basically ancient humans, but that's not really true. We come from the same genus called Homo, but we, all modern humans, belong to one same species called Homo sapiens. However, there used to be lots of human species before, and Homo neanderthalensis was just one of them. And they actually were kind of cooler than us. So what in the world has happened to them? Neanderthals lived for a long time, for about 360,000 years, across Europe and parts of Asia. 40,000 years ago, the place we now call southern Italy was sitting on top of a huge disaster, a massive supervolcano called Campi Flegrei. This big boy is huge, about 9 miles wide. That's about 10 to 20 minutes in a car to get across it all. But there were no cars then, remember? At the time, it was quiet for a while, but one day, suddenly, it blew in what became one of the biggest volcanic eruptions Europe had seen in 200,000 years. The catastrophe was so crazy that ash, gases, and debris altered the climate across the entire continent. What comes next is usually called a volcanic winter. Average temperatures drop, the sky gets darker, and life becomes even harsher than it already is. The eruption, known as the Campanian Ingembrite, caused Europe to cool by as much as 7 degrees Fahrenheit. Doesn't sound like much? Well, the drop of even 1 degree would cause winters to become harsher, causing horrible snowfall, rains, and floods. Crops would struggle to grow, leading to food shortages. The weather would go wild, too, with storms and droughts. Hey, kind of like now. Except multiply this by 7. Events like these caused some huge chaos in modern times. You can imagine what it did to the Neanderthals. But in reality, a simple volcanic eruption shouldn't destroy an entire species, right? Well, yes. The truth is, the Neanderthals were already hanging by a thread back then, and all because of us. They've been in a tough spot for a while. They lived in places that are now parts of Europe, Western Asia, and the Middle East. Modern humans, us Homo sapiens, entered Europe and were giving them some serious competition for food and shelter. Homo sapiens were sneaky dudes, better at finding food, easily adapting to different environments, and using more advanced tools. We were pushing Neanderthals out, trying to get the same resources. We literally made their extinction a slow and very unpleasant process. So, while the volcano definitely made things worse, it wasn't their only problem, and they didn't completely disappear after the eruption. Some of them hung on in isolated places, like Gibraltar, for another 12,000 years. That's because it's likely most of the severe cooling actually happened farther east, away from where the Neanderthals were trying to survive, and it didn't hit their homes as hard as we thought. In fact, the eruption may have even helped them, at least for a while. Some scientists say that the volcanic fallout might have slowed down modern humans' expansion into Neanderthal territory and gave the poor fellas a little more time to survive. So, the Campiflagre eruption was a nasty event, but it only delayed the inevitable. Campiflagre is a wild card. It's also known as the Fields of Fire. The air itself there is thick with legend. The Greeks and Romans believed this volcano was the gateway to the underworld. Even an ancient Roman poet, Virgil, mentioned this in his famous story, the Aeneid. The hero Aeneas must descend into the underworld, and this place is exactly where he starts. Back in the day, this landscape was full of Roman villas, spas, and fish ponds. The elite had the time of their lives there. What they didn't know, though, was that they were standing on treacherous ground that could go crazy at any moment. The Campiflagre is not your typical volcano. You'd imagine a single towering peak, but the landscape looks deceivingly calm, with small features popping up here and there. But if you flew above it, the sight would be insane. A gigantic circular basin, peppered with volcanic cones and craters, like scars from the Earth's violent past. The danger here lies in its subtlety. The ground beneath your feet is constantly shifting, even when you don't notice it. Every so often, the land rises, only to sink again, sometimes by several feet, as magma or gas moves beneath the surface. It's incredibly creepy. The risk is almost invisible. The Campiflagre is a massive depression formed by two colossal volcanic eruptions. One of them was the one that cooked Neanderthals, and another happened 15,000 years ago. The most famous eruption, though, happened in the 16th century, and it was horrifying. The year was 1538. For years, the people of Paswali had noticed something unsettling. Land that once sat below the waves was slowly rising. What was once the sea had become new ground. Rumblings from deep within the earth were terrifying, but had become a normal part of life. Earthquakes started in the early 1530s, small at first, but in just 8 years, they became the norm. Until one day, on September 28th, horrifying tremors shook the ground. By the next evening, as the sun dipped below the horizon, a massive crack ripped open the earth near the ancient Roman town of Tripurgoli. From this gash spewed fire, smoke, and a rain of volcanic ash miles away. It was thick and muddy, likely mixed with underground water. The ground trembled as hot pumice rock was thrown high into the air. And then a new mountain began to rise from the land. This was the birth of what we now call Monte Nuovo. Eventually, things seemed to calm down, as if the earth was catching its breath. For days, things seemed quiet. Locals relaxed a bit. They began to approach the new mysterious volcano, a crater with something that resembled boiling within it. People visited it like a new attraction. But then, just days later, the disaster struck again. At night, without warning, a new mountain went wild. A blast from the southern flank hurled scoria, chunks of jagged volcanic rock, into the air. This one was fatal for 24 people. The debris found afterwards was huge and coarse. For centuries after, the only signs of life from the Monte Nuovo were small fumaroles, jets of gas seeping from the earth. But then, even those faded away. Now it's just a lush green cone, a pretty sleeping giant. But the ground near Naples, Italy, is still alive. The Campiflagre sits quietly for now, but it might not be for long. It's showing signs it might be waking up again. This supervolcano looks like a hellish landscape, with its boiling mud pits, geysers, and steam vents. Romans and medieval Christians once believed it was a gateway to the underworld, and who can blame them? What's spooky is that recently scientists detected unusual activity under the surface. In 2012, Italian authorities raised the alert level on the volcano from green to yellow, meaning that it needs close monitoring. There are certain changes that usually happen before an eruption. The magma below starts releasing gases, which could weaken the rock above, eventually triggering a disaster. Unfortunately, no one can predict exactly when or if it will erupt. But if it does, the consequences could range from a minor inconvenience for locals to a global catastrophe. Its last tiny eruption happened in the 16th century, and it wasn't too bad. But if history repeats itself, like it was with Neanderthals, we're all cooked. An eruption like that could lead to global cooling, crop failures, and widespread famine. Right now, a group of scientists is trying to get a clearer picture of what's happening beneath the surface. The Compiflagrate Deep Drilling Project is working to drill a 10,000-foot borehole, hoping to check out the magma chamber up close. But at least for now, the supervolcano remains quiet, and let's hope it stays that way.
Hello, Brightsiders! Do you know where the deepest place in the world is? I think it's in the Pacific Ocean, near the Philippines and Papua New Guinea. It's the famous Mariana Trench. So let's take a tape measure, a very long one, and attach its end to the boat on the surface. Now we hold our breath and jump in the water. Fish and marine animals swim by. We descend lower to the depths and into total darkness. And after several hours, we reach Challenger Deep. The tape measure shows a depth of 36,200 feet. The famous Mariana Trench is not the deepest place on Earth, as everybody thought. The Kola super deep borehole, located in Murmansk region in Russia, beats it by a wide margin. And scientists have discovered something unusual and sinister there. When geologists were drilling the hole, they could reach the depth of 9 miles. And then they encountered voids. Scientists on the surface were surprised and scratched their heads and then decided to lower a microphone and dozens of other sensors in these voids. The temperature down below turned out to be 2,000 degrees Fahrenheit, and the microphone recorded something that sounded like human groans and screams. Many people thought the scientists had been able to drill into the underworld. The shocked people up above had already begun to panic, but suddenly an unknown creature jumped out of the drill pipe. It looked like a black goat that walked on its hind legs. Its body was shrouded in black flames. The creature got out of those deep hollows and ran off into an unknown direction. Okay, wait. These are just myths that one newspaper published on the 1st of April. It's International Joke Day, by the way, but many people believed it. It made many believe the scientists working at the borehole had opened a portal to the nether, and that now horrible, outworldly creatures were free from their imprisonment. But like with any myth, there's some truth to it. The deeper the scientists drilled, the higher the temperature got. At 3 miles deep, it was 160 degrees. At 4.5 miles, it was 250. And at the maximum depth of 7.5 miles, the sensors recorded a temperature of 413 degrees. One day, scientists heard a loud explosion underground. They stopped working and everyone tried to find out what caused such a loud pop. But there was seemingly nothing there. After a while, they continued drilling deeper, and at the same depth, no accidents happened. The drilling began in May 1970. They passed the first 4.5 miles quite easily, and it was primarily hard granite rock. It was like drilling through a hard wall. But then their drill went into softer layers, and the shaft of the hole began to crumble. It was like drilling in wet sand. Every time the workers took the drill out, there was a risk that the hole would collapse under its own weight. As that eventually happened, the scientists picked a new direction to drill, and you know what's interesting? In the end, the map of the entire well looked not like a straight beam from top to bottom, but like a tree trunk which had diverged into many different routes. 9 years later, scientists reached the depth of 31,400 feet and broke the world record for the deepest borehole. By 1983, they made it another 8,000 feet deeper. After a brief pause in the work, there was an accident. A part of the drill broke away from the main body and remained in the borehole. For several months, scientists tried to extract the drill, but nothing worked, and they had to return to the depth of 4.5 miles and start all over again. The drill was divided into sections, and one such unit could only last about 4 hours before it had to be replaced. In terms of depth, that was only about 32 feet of drilling. Then the drill was lifted to the surface, replaced, and lowered back down. On average, the drilling speed was about 200 feet per month. That's like a 20-story building. In 1990, 20 years after the work had begun, scientists reached the final depth of 40,230 feet. That's like 100 soccer fields down. And after another accident, the work stopped. Guinness World Records registered the Kola super deep borehole as the deepest borehole in the world. It's like Mount Everest plus 9 Empire State Buildings on top of it. One of the most unusual discoveries at the Kola super deep borehole was that the soil at the depth of about 2 miles almost perfectly matches the composition of the surface of the moon. It has given us more insight into how our ancient satellite appeared and formed. It seems that in the early stages of Earth's formation, a giant asteroid crashed into our planet. With that kind of force, it caused an explosion so powerful that part of our planet broke off and flew upward. This chunk of Earth remained in our planet's orbit, cooled, and later formed into the moon we know today. Another surprise for the workers was the presence of gold. There was about 2.5 ounces of gold for every ton of soil lifted. The deeper the scientists went, the older the rocks were. In layers of rock about 2.8 billion years old, they found fossilized remains of living organisms. It made the world of science bubble with excitement, as it meant that life on our planet appeared 1.5 billion years earlier than first thought. In the early 1990s, they shut down the drilling project. Gradually, the buildings around the borehole and the drilling equipment were lost. Today, a lot of tourists visit the place. It's because of those same myths about creatures from the underworld. Yes, there's a hole 7.5 miles deep under that rusty lid. But the scientists working there never reached their goal. They wanted to drill into the Earth's mantle, but to do that, they would have had to dig down to a depth of about 44 miles. At 200 feet per month, it would have taken as long as 80 years. That's assuming no accidents happened. But the deeper it goes, the more interesting it gets. A few years ago, they found a massive amount of water deep underground. Somewhere up to 370 miles down, there's a substantial ocean billions of years old, and the amount of water there is several times greater than in all the oceans, seas, and rivers combined on the surface of Earth. The water there is at a scorching 2,800 degrees Fahrenheit. But because it's under a tremendous pressure, it doesn't evaporate. It's encased in a crystalline structure of minerals. This ocean was formed in the early stages of our planet's development, when there was only hot lava and debris of space bodies around. But the most exciting thing you can find by drilling is living organisms. They've been there in isolation for billions of years, and they can give us clues as to how life came into being in the first place. Scientists in Antarctica have created a similar borehole. An entire lake half the size of Lake Ontario was discovered under the thick ice. The amount of water in this lake is only 3.5 times less than in the Lake Baikal, the largest lake on Earth by volume. The ice that hides this lake is at least 20,000 years old, and the water beneath it has been isolated from the outside world for about 15 million years. While drilling, scientists lifted a chunk of ice from deep down below and found an unknown bacterium on it. Its genetic code was only 86% similar to known living organisms. That means that we've never seen bacteria like this before, or it had come from outer space. But that's just a theory. We know that these bacteria can live in unusual conditions and at water temperatures below freezing. The composition of underground lake water is also different from what we're used to. There's a lot more oxygen and carbon dioxide in it. Add to these conditions complete isolation, and we get living organisms that have developed and evolved in a completely different way. Do you understand what it means? The study of deep organisms may give us a clue as to whether life could exist beneath the ice on other planets or their moons. For example, Saturn's moon, Enceladus, has ice 24 miles thick. There may be an ocean underneath, which is heated by thermal springs. That's all for today. And guys, remember, let's become smarter every day together with Brightside.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more. But getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city, except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. Name a desert. Let me guess. Sahara? Well, actually, no matter which one you thought of, I'm sure of one thing. It's located somewhere below this line. See, when we hear the word deserts, we usually picture dry, sandy, blazing hot places, and there's not a single one of those above 45 degrees north latitude, or below 45 degrees south. In the south, that kind of makes sense. I mean, if you leave out Antarctica, there's not a whole lot of land down there. But things are different above 45 degrees north. There are tons of land. Countries like Canada, France, the United Kingdom, and a bunch of others. And still, not a single desert. Actually, not a hot desert. Most of the major hot deserts are up in the northern hemisphere, near the tropics of Cancer and Capricorn. And the hottest ones are usually found between 15 and 30 degrees north or south of the equator. Just like the Sahara, where average high temperatures can reach up to 104 degrees Fahrenheit. Together, hot deserts cover almost 15% of the Earth's land area. But if our planet is packed with them, why doesn't a single one appear above this line? I mean, the 45 degrees north latitude. I'll explain. Let's divide Earth into 5 main zones. The polar regions are located at both ends, north and south. Right here, we have the 2 temperate zones. And finally, right in the middle of the globe is the tropical zone. Now, the line we're talking about sits in the temperate zone, in a colder area. Because the farther you go away from the equator, the colder it gets. Actually, the average annual temperature drops about 1.2 degrees Fahrenheit for every degree of latitude you move north in the northern hemisphere. And cold weather is the main reason hot deserts don't form above this line. It turns out that as you move farther north from the equator, the sun's rays hit the Earth at a more slanted angle. That spreads the solar energy over a larger area, which means less heat is concentrated in one spot. Basically, these regions just don't get as hot. And it's one of the reasons why countries like Finland are much colder than Colombia, for example. Another reason temperatures are lower in this zone has to do with something called albedo. Basically, this term refers to the amount of sunlight that a surface reflects back. Let me give you an example. Every surface on Earth both reflects and absorbs sunlight, but in different amounts. Take snow, for example. It can reflect up to 90% of the sunlight that hits it and only absorbs about 10%. That's what gives snow a high albedo. And it's totally different with sand, which has a lower albedo. In places like the Kalahari Desert, down in southern Africa, it's about a 50-50 situation. Most of the year, roughly 50% of the sunlight gets reflected around there, and the other 50% is absorbed. The heat absorbed by the sand is part of why it gets so hot in dry places like deserts. I mean, hot deserts. Simply put, sand soaks up more heat, while snow reflects most of it. This is one of the reasons why snowy areas stay much cooler. So the closer you get to the polar zones, the easier it is for sunlight to be reflected instead of absorbed. And that helps explain why there aren't any hot deserts around those parts. Then, we also have atmospheric patterns. Let's just say that the air patterns change a lot once you go above that 45-degree line. That's because this region is controlled by a wind belt known as the Ferrel Cell. Okay, so Earth has 3 main convection cells. You can think of them as big loops of moving air. Warm air rises, cools down, sinks, and then the cycle repeats. At the top and bottom of the planet, we have the polar cells. Right in the middle are the Hadley cells, and sandwiched between those two are the Ferrel cells. Now, everything that happens between these 3 cells can get a little complicated, but for today, the main thing to know is this. In those middle zones, the warm air that comes from the tropics meets the cold air from the polar regions. So, Ferrel cells play a big role in moving heat from the equator up toward the poles. This flow of warm air helps smooth out the temperature differences between the tropics and the polar regions. And that's what shapes the weather in places like North America, Europe, and parts of Asia. In the mid-latitudes, the Ferrel cell keeps the air moving around so much that hot, dry air doesn't really get a chance to settle. So, those regions end up with more moisture, more clouds, and even storms, rather than dry, desert-like weather. That's why you don't usually see hot deserts around 45 degrees latitude. Basically, what I'm trying to say is that the Ferrel cell makes the weather less stable. And that's very different from what happens in the Sahara Desert, for example. Over there, temperatures don't change all that much throughout the year. Just expect it to be hot. When you put all these factors together, it helps explain why hot deserts are mostly limited to the middle parts of the Earth, and why you'll never find a Sahara or Kalahari-style desert in places like Canada or Sweden. But that doesn't mean we don't have any deserts above the 45-degree line. Turns out, deserts don't always have to be hot and sandy. In fact, they can look like this. Yep, I'm talking about the Arctic. Because the actual definition of a desert isn't just some hot, dry, sandy place, it's really any area that gets very little precipitation. In other words, an area where it doesn't rain much. And it usually gets no more than 10 inches of precipitation per year. So no matter if the weather is hot or cold, deserts are really dry places with hardly any vegetation around. That makes it pretty tough for animals and plants to live in those environments. If you think about it, that means the biggest desert on Earth is Antarctica. It covers about 5.5 million square miles, just endless ice flats as far as the eye can see. It's also the coldest desert on the planet, even colder than the Arctic, which is the other polar desert. Temperatures there can drop as low as minus 128.2 degrees Fahrenheit. If you look at the Earth, about 33% of its land is desert. Now, pay close attention to the ones located between 15 and 30 degrees latitude. These are called tropical deserts. But can you notice something curious about their locations? Most of them are found on the western edges of continents. And there's a reason for that. Actually, 4 main reasons. First, the winds that bring rain usually blow from the east. When they move across the land, they drop most of the rain early on. By the time these winds reach the west side, they're dry, so there's no rain left for those areas. That already makes things pretty dry. Second, in the western margins of continents, the air usually goes down instead of up. When air goes down, it gets warmer and can't form clouds, so again, no rain. Third, if there are mountains nearby, they can block the rain too. One side of the mountain gets all the moisture, and the other side, called the rain shadow, stays dry. And lastly, the ocean near these places often has cold water. Cold water cools the air above it and makes it calm, so clouds don't form easily. No clouds means no rain. So when you put all of that together, it helps explain why those tropical deserts seem to prefer one side of the continent more than the other. In Asia, there's a bridge that is way longer than you'd think should even be possible. The HZMB stretches 34 miles over open water, which makes it the longest sea bridge in the world. So if something this massive can make it across rough waters, why can't New Zealand just build a bridge between its 2 main islands? After all, we're talking about a distance of just 14 miles. And a bridge like that could seriously change life for both locals and tourists. People could just hop in a car and drive from Wellington to Picton. No more ferry hassles, no more drawn-out trips. Just one epic road journey with ocean views on both sides. So what's stopping them? Well, turns out, everything. I mean, building a bridge there is technically possible, but there are a couple reasons why experts are like, maybe not. Let's start with the obvious, the distance. The North Island and the South Island are separated by Cook Strait. Like I said, it's 14 miles wide at its narrowest point. That's not much, true. Plus, we've got the HZMB bridge, proving that, yep, it is technically possible to build a bridge over the sea to cover that distance. But we can't ignore the fact that New Zealand's geography is, well, a whole different ballgame. Cook Strait isn't exactly a calm, friendly stretch of water. It's deep, really deep. Parts of it drop to about 10,000 feet. That's like stacking 7 Empire State Buildings on top of each other. It's also a rough, moody stretch of ocean that loves tossing around ships like rubber ducks. In fact, quite a few have been wrecked in Cook Strait. And sadly, many lives were lost. You don't have to worry about it so much though, as the worst accidents happened a long time ago. The ships and ferries that cross it today are much safer. Even so, it'd be pretty hard to avoid getting seasick while crossing it. Things get even messier below the surface. The seafloor over there is uneven and unpredictable. What happens is that Cook Strait has opposing tides at each end, one where it meets the Tasman Sea and the other where it joins the Pacific Ocean. And they simply don't move together like you might expect. When the tide is high on one side, it's low on the other, and they're totally out of sync. So all that water rushes back and forth through the strait to balance things out, creating some really strong and messy currents in the middle. Then there's the weather. Cook Strait isn't just windy, it's probably one of the windiest places in the southern hemisphere. That's because it's located right in the middle of one of New Zealand's 3 big wind tunnels. Basically, there are places where the wind doesn't just come and go quickly. It sticks around, blowing hard for most of the year. And all of this happens because of something called the Roaring Forties. That's the name for the latitude band between 40 and 50 degrees south of the equator, where strong, persistent westerly winds are pretty common. Unlike the northern hemisphere, which has a lot of land at this latitude, the southern hemisphere is mostly ocean with just a few land masses, like New Zealand's South Island, Tasmania, and the southern tip of South America. So, these winds go wild because there's nothing to slow them down, and they just keep picking up speed. The gusts there can reach up to 150 miles per hour. So, imagine trying to cross a bridge in a car when the wind is actively pushing against you. That's not just unpleasant, it's super dangerous. Drivers can easily lose control of their cars with the wind pushing them sideways. And of course, that can lead to countless serious accidents. Now, let's talk about earthquakes. New Zealand sits right on the boundary of 2 massive tectonic plates, the Indo-Australian and Pacific plates. It's basically in the middle of a collision zone. And about 14,000 earthquakes happen in and around the country every year. Of those, only about 200 are big enough to be felt. Still, building a massive bridge under these conditions would require some serious genius-level engineering. With all that in mind, we can safely say that the whole bridge idea is off the table. But how about an underwater tunnel? Yep, that could work. It could be a great solution actually. No wind, no bad weather, and no earthquakes to deal with. There are a bunch of other advantages too. First, it would dramatically reduce travel time, cutting down the 3 to 4 hour sailing trip between the North and South Islands. That same journey would probably only take about 40 minutes. Then people wouldn't have to stress about all the ferry cancellations and delays because of bad weather. And most importantly, it's doable. I mean, look at the Channel Tunnel. It's an undersea tunnel connecting southern England and northern France. Japan did something similar with the Seikan Tunnel, which connects the islands of Honshu and Hokkaido. They are both huge projects, serving pretty much the same purpose. So why on earth isn't New Zealand already building this tunnel? Well, for the same reason we don't all live in luxury treehouses with personal robots. Money. Estimates vary, but some experts think a project like this could cost anywhere from $10 to $20 billion. To cover that kind of cost, they'd probably need to charge tolls for the next 100 years. And trust me, those tolls wouldn't be cheap. Other experts think it could actually cost more than that. Because you see, we have to consider all the extra infrastructure. The narrowest point of Cook Strait is between the North Island and Arapahoa Island. That's one of the long, mountainous regions in the Marlborough Sounds, which is pretty remote. So it's not just about the cost of the bridge or tunnel itself, it's also the access roads, safety systems, maintenance, and evacuation plans. You can't just build a huge underwater tunnel and not plan for the occasional emergencies. And what would it actually be used for? Sure, there are people who travel between the islands. About 1 million passengers take the ferry every year. But that's not exactly the kind of traffic that justifies the most expensive infrastructure project in the country's history. Earlier, we talked about how England and Japan have similar underwater tunnels. But there's something to consider. The United Kingdom has a population of 69 million. Japan has even more, with around 123 million people. And in New Zealand, they've only got 5 million residents to pay for this project. So could they have a tunnel under Cook Strait? Sure they could. Should they? Probably not. If you don't want to fly, the only other way to travel between the islands is by ferry. It's not ideal, but hey, it works. New Zealand has a total of 5 ships that transport people and vehicles across the islands. For tourists who aren't in a rush, it's perfect. You can cross the islands while taking in some of the most stunning views and spotting amazing wildlife. You'll start your trip in Wellington, and right from there, you'll see the rugged North Island coastline as you head out into open water. You might see different seabirds like gulls and terns, and as you get closer to the South Island, you might spot some gannets. If you're lucky, you could also catch a glimpse of the seal colonies off the coast. During the last hour of the trip, the ferry will slow down, giving you plenty of time to enjoy the green hills and calm waters. You will also approach Queen Charlotte Sound, a spot known for its wildlife. So keep an eye out for orcas, playful dolphins, and even penguins. Honestly, having a ferry instead of a tunnel might not be so bad after all.
A huge power outage hit Spain, Portugal, and parts of southwest France all at once, leaving millions of people without electricity. It happened on Monday morning, April 28, 2025, and caused lots of problems. Airports couldn't function, trains stopped in places like Lisbon and Madrid, and some hospitals had to cancel surgeries because they had no power. Everything just came to a stop. No one is sure yet what caused the blackout, but the company in charge of Portugal's electricity said it might have been something strange called induced atmospheric vibration. That's a rare and weird thing that can happen in the sky and might mess with power systems. It occurs when substantial changes in temperature and wind mess with giant power lines, making them wiggle and shake in strange ways. These wobbles can confuse the power system and cause big problems. So REN, the company that runs Portugal's electricity, first said that those weird wobbles might be the reason everything went dark. But later, they said that was not really what happened. According to REN, the real reason for the blackout was a huge voltage change, like a power surge, in Spain's power grid. At that moment, Portugal was using electricity from Spain. When that enormous power fluctuation hit, it triggered automatic safety systems in Portugal. Those systems shut everything down to protect power plants. Sadly, it also caused a nationwide blackout. During extreme weather in Spain, the air temperature changes fast, and that makes immense power lines stretch or shrink like rubber bands. That changes how tight they are and how they move in the wind, which can mess with both their physical balance and the electricity flowing through them, making the entire system unstable. Some experts say that if things get bad enough, this can even break power lines, cause short circuits, or even damage the towers holding up the lines. That's why safety systems are always in place. They're supposed to shut parts of the grid down automatically to stop bigger disasters. During the blackout, something like a domino effect happened. When parts of the power grid shut down, it made other parts unstable too. Some of the big electricity generators couldn't handle the chaos and had to disconnect. And when you suddenly lose those big generators, the power system can't keep up. It's something like too many people needing electricity, but not enough of it being made. It can cause even more blackouts to spread fast. Nobody knows exactly what started the blackout. Some people wondered if it might have been a cyber attack, like someone messing with the system on purpose through computers. But officials from Spain and the European Commission said that there was no proof of that. Spain's electricity company made it clear. Cyber attack? Nope, that's not the problem. Still, one big reason so many places were hit is because Europe's power grids are all connected like one big web. Usually, that's a good thing, since if one country has a problem, another can help by sharing electricity. At the same time, everything has to stay super balanced. The amount of electricity being made must match how many people are using it. If even one part gets knocked out, it can mess things up for other parts nearby, especially if they were depending on it. In other words, when something big goes wrong, it can travel through that web and cause problems in lots of countries at once, just like what happened in this case. And it's not the first time this kind of thing has happened. Back in 2003, most of Italy had no power for 12 hours because of a problem with an electricity line connected to Switzerland. In 2006, overloading of lines coupled with low temperatures caused too much power to surge through Germany's grid, which ended up knocking out power in many parts of Europe. Anyway, speaking of the recent blackout, by Tuesday morning, things started getting better. Most of the lights came back on across the Iberian Peninsula. That's Portugal and Spain. All of Portugal had power again, and 99% of Spain did too. Now, the people in charge are trying to figure out exactly what went wrong and how to make sure it never happens again. So yeah, power grids are awesome when they work. When things go wrong, they can go really wrong. Now, let's travel back into the past, to the year 2012. Long time ago, huh? That's when India had one of the biggest blackouts in history. More than 600 million people lost electricity. It's like half the country or the entire population of Europe. This huge mess happened when 3 enormous power grids all broke down at once. Yep, those very grids that move electricity around. So when they fail, the lights go out everywhere. Because of this, entire cities just stopped working. Trains couldn't move, water pumps stopped, traffic lights went dark, and people were stuck all over the place. In Delhi, the capital city, the metro shut down, and passengers had to be helped off the trains. Without traffic lights, the roads turned into giant traffic jams. The blackout hit 20 of India's 28 states, including big ones like Punjab, Haryana, Uttar Pradesh, Rajasthan, and West Bengal. In West Bengal, around 200 miners got stuck underground because the elevators stopped working. Luckily, they were all rescued safely. Engineers worked all night to fix things, and by the next day, they managed to get the power back on for all 3 grids. In India, smaller power cuts happen a lot, especially in cities. That's because the country doesn't make enough electricity for everyone, and the equipment they use is pretty old. But a full grid collapse like this is rare. Before this, it happened in northern India back in 2001, so when it happened again in 2012, and across 3 grids no less, it was very important. Everything just shut down, and it showed how much the system needed fixing. But blackouts like these happened in Europe before too. Back in 2006, something weird happened because people in Germany got cold. It was a chilly Saturday night, and families in northern Germany turned on their heaters all at once. This sudden spike in energy use put a huge load on the power grid. To make things worse, one major power cable had been turned off for a bit so a ship could pass under it. Ooh, talk about bad timing. The grid couldn't handle everything, and it started breaking down. First, Western Germany had blackouts. Then things started going wrong in France, where even the big French power company, EDF, couldn't keep up with demand. Before long, power was going out in Paris, its suburbs, and other parts of the country. Then the trouble spread to Italy, Spain, and Belgium, and even Morocco. Millions of homes were left without power. In France alone, about 5 million people were left in the dark. Trains stopped running, and fire crews got loads of calls from people stuck in elevators. One of the people in charge said the whole thing started falling apart like a house of cards. Country after country started pulling power from France, which only made things worse. To stop a total blackout across all of Europe, they had to shut down some electricity for a short while on purpose. Over in Italy, the lights went out in both northern and southern regions. This country often imports electricity from other places, so it got hit hard. A few years earlier, in 2003, most of Italy had gone dark during another big blackout. Belgium had its own problems, while Spain saw power cuts in some of their larger cities. Even trains and high-speed rail had to stop in some places. It all started because too many people needed electricity at the same time, and the European power network couldn't keep up. Experts later said that the whole thing showed just how badly Europe needed to update and fix its old electricity systems to stop something like this.
Closing the North Sea in a nearly 400-mile-long dam may save Europe from complete disaster. This is not some sci-fi stuff. It's real, and it's called NEED, Northern European Enclosure Dam. It's a last-ditch plan to save over 25 million people from 15 European countries from the rising sea levels. To build this giant bathtub, humans need one dam between England and France, another one between Norway and Scotland, 51 billion tons of sand, and almost 600 billion euros. As crazy as it may sound, this project is totally feasible, except for one teeny tiny detail. The scientists who had this literally life-saving idea don't want the dam to be built. First and foremost, the NEED needs, two dams. One that is 100 miles long and almost 334 feet deep in the English Channel, and another that is 300 miles long and more than 1,000 feet deep in the North Sea. Building something like this requires a crazy amount of materials, like the 51 billion tons of sand we mentioned before, which is basically all the sand everyone on the planet uses in a year. And yes, this dam would obviously be the biggest in history, smashing records like the Netherlands' 19-mile Afsluitdijk and South Korea's 20-mile Semangam seawall. The NEED Dam would be 19 times bigger than Semangam. It sounds ridiculous, but it's not impossible. You see, humans are pretty good at building big stuff. Oil rigs, for example, operate at depths of up to 6,500 feet, and the NEED Dam would only go down more than 1,000 feet. Plus, China has a 102-mile-long bridge, and the dam would only be 4 times longer. Besides, projects like this dam were done before for the exact same reason. It's our friend Afsluitdijk in the Netherlands, which was built almost 100 years ago. The idea here was to shut off a part of the North Sea called Zuiderzee and protect the Netherlands from all the flooding because most of the country is below sea level. They even drained one of the lakes formed by the dam and created a whole new province, Flevoland. Today, the Netherlands has more than 2,200 miles of flood protection, but it's only designed for a 15-inch sea level rise. Without it, the country would be underwater. So yeah, we could do it, but it's really, really expensive. How expensive? Well, it would cost around 550 billion euros if the project is wrapped up in about 20 years. One wrong step and humans can spend 100 years building this dam, and a couple of billion euros more. The good news is that this much money can be diluted over the 20 to 100 years it takes for the dam to get finished. Besides, the 15 countries it would protect could share the expenses, reducing the amount to only 0.1% of the GDP of all the countries. Not a bad deal to save millions of people, right? Okay, but is this monstrosity really necessary? Well, unfortunately, humans have managed to turn the ocean against us. This means that by 2100, the sea levels are expected to have risen between 1 to 2 feet. If we keep acting like it's none of our business, the rise can reach more than 16 feet by 2300. It may sound like a distant future, but NASA has just discovered that the ocean rose way more than they expected in 2024, which means global disaster is breathing down our necks as we speak. Let's go back to our geography classes for a moment and learn why sea levels are rising altogether. First, because land can sink. The city of Norfolk, Virginia, for example, was built inside a massive crater, and the earth there can erode and sink. Then the soil can get compacted. Because of that, the city is literally sinking into the ground, making it more vulnerable to flooding. In California, some areas are sinking too, but this time it's because of the movement of tectonic plates. Some of the land that is underwater goes up, some of the land over the water goes down. The consequences? Again, heavy flooding. Sea levels also rise if the planet gets too hot. This happens because of a thing called thermal expansion. It has a very scientific name, but it basically means that things like water get bigger if the temperature rises. Half of the reason why sea levels are rising is because of this. This is why the level of the ocean increases almost 10 feet every time the average temperature of the planet rises by 33.8 degrees Fahrenheit. Since 1880, the sea has risen more than 8 inches. Okay, so we build the Need Dam and the problem is solved, right? Well, building this dam comes with massive consequences. First, the ocean currents, think of them as underwater highways that deliver nutrients to tiny creatures like planktons, not the SpongeBob villain, and give rides to animals like lizards and tortoises. A dam this big is capable of messing up the ocean currents that bathe Europe, disrupting the food chain not just inside the dam, but outside too. The currents are also responsible for the climate of coastal areas. The Gulf Stream, for example, is a warm current that comes all the way from Mexico and makes the weather in northwestern Europe a bit more bearable. If the Gulf Stream got interrupted by a gigantic oceanic barrier, it could make parts of Europe even colder. Another problem is that the North Sea would turn into a gigantic freshwater lake. This would happen because the salt water that used to flow from the ocean would now be blocked. And the North Sea would only be fed by the fresh water coming from inside the continent. This process would eventually lead to a thing called desalination, when salt water gets less salty. And it's really terrible because saltwater animals would start to absorb more water than they should, making the cells of their bodies swell. The consequences can be fatal. The disruption of the ocean currents by the dam can also affect the renewal of oxygen in the water. Think of the ocean as a giant recycling system. Surface water needs to sink to deliver oxygen to the deep sea, keeping creatures dwelling at the bottom alive. Without the movement of ocean currents, oxygen would run out and toxic bacteria would take over, creating a poisonous environment for sea creatures. And this is not just a theory. It happened before, 250 million years ago. The ocean got so toxic, it wiped out 95% of marine life and caused a mass extinction. If it's not bad enough, the fishing industry would collapse, and the busiest trading ports of Europe like Rotterdam, Antwerp, and Hamburg would be stuck inside the dam. Sure, we could build sluice gates, but imagine all those traffic jams. The rain patterns of the countries protected by the dam would change too, affecting farming lands and food production. On the other hand, if we do nothing about rising sea levels, permanent flooding could make whole countries disappear. 3 million people on the islands of the Pacific would need to move away by the end of the century. The Maldives would lose 77% of its territories, and cities like Jakarta, Bangladesh, and Lagos would go underwater. Storms would get more dangerous too, destroying treatment plants for sewage and power stations and contaminating farmlands. Rising salt water could also contaminate freshwater supplies, and it's not just happening in Asia and Europe. Philadelphia, for example, is already developing plans to deal with this bleak scenario. This is why the scientists who developed this big red button shaped like a dam don't want people to actually build a dam. They know how bad things can get, which is why they came up with a plan so wild it's basically the engineering version of screaming, "Hey, stop ignoring the planet!" It's a warning. If we don't act now, we'll be stuck building mega dams just to keep our cities from becoming Atlantis 2.0. And let's be honest, nobody wants to live in a future where the apocalypse looks like the deep web version of The Little Mermaid.